All right, I think we're live. Yeah.
Awesome. Cool. All right, how does the screen look? Can you see the screen okay? Yeah, okay, awesome. So I guess we can get started. So welcome everyone. This is the Google Cloud Study Jam, where we're gonna go over the Qwiklab of Google Cloud Essentials. We're really excited to give this workshop to you, and hopefully you get to learn some awesome cloud skills in the meantime. So just to introduce ourselves, we are all students, part of the DSC from Google Developer Student Club. So my name is Miranda Harrison. I'm one of the workshops and talks co-leads at McMaster. I'm currently studying computer engineering, and I'm also hoping to pursue a career related to cloud. So I'm a big cloud advocate, that's for sure. I'll let the other speakers introduce themselves, starting with Shardul.
Hey everyone, hopefully you can hear me. My name is Shardul. I'm also a final year student studying computer at McMaster. Also gonna go into summer, I'm gonna do software engineering and also cloud computing, more on the infrastructure side of things. So I'm excited to be bringing this workshop to you guys. I'll pass it on to Kathy, who's from Ryerson, to introduce herself.
Yeah, so we're really excited to be doing this with McMaster. So I'm from Ryerson. I am somewhere in between second and third year in computer science. I personally am interested in web development, front end, back end, and UX. So, this whole cloud thing really comes into play when we're dealing with large scale web applications. So that's it for me. I think we can sort of move on. I'll pass it back to Miranda.
All right, thank you guys. So just an extra shout out to Ryerson. This is our first event that we're collabing with Ryerson or any university for another workshop. So McMaster is really excited to be working together with Ryerson. All right, so just we're gonna go over first like our agenda and some logistics. Next, we're gonna have an introduction to cloud, and then we get started with this hands-on lab. So this event today is going to be really hands-on, but I feel like that's one of the best ways that you can learn. So let's go. Here's the approximate agenda. So we're gonna, like I mentioned before, we're gonna have a quick intro about like 15 minutes. And these numbers here are the recommended time to complete the Google Quicklabs. So they give us, like, for example, 30 minutes to complete the first lab. I honestly think you can complete it in much less time. Probably we will as well. But we wanted to give this agenda with the recommended times just to work out all of the logistics if there's any errors or anything. Something else to mention is that because the platform is YouTube Live, feel free to pause, rewind. You don't need to finish the whole study jam when we do. We're going to give you access today, and then you have 1 month free access. So technically you have 1 month to complete this whole thing. So we split it up that we're first going to do the first 3 labs all at once. So the first 3 labs, it sounds a lot, it's 3 different things, but it's not so bad. All of these labs are kind of more introductory, getting you used to Google Cloud Platform and even how these labs work. So after the first 3, we're going to have a 15-minute break. And the last 2 labs are a bit more advanced, but we're going to do them together. And after that, we can show you how to share your Google Cloud badge, hashtag Cloud Study Jam, and so you can share it on LinkedIn or any of your social media that you've now completed this Quicklabs course. Okay, so yeah, just some logistics of the event before we get started. So like I mentioned before, this event will be streamed and recorded on YouTube Live. So Yeah, here's the link. I guess you're all watching it on there now, but like you can always go back, rewind, watch this tomorrow, anything you like. So another thing is to join the McMaster DSC events Discord server. So I don't know, Shardul or Shashank, would you be able to drop the link in the chat to join this Discord server? And at the same time, I can show you how it works.
Yep, the event Discord link should be right in the YouTube live channel.
Perfect. Okay, so it's not required for you to join this Discord channel, but I highly recommend it as it can give you help during the actual event, as well as keep you updated with some of our other events. So when you first log on this event, this server, you first have to accept the rules, and then you get access to all of the other channels here. So if you see there is this Cloud Study Jam, this is our channel that if you have any questions or anything related to this Cloud Study Jam, you can post it in here. As you can see, I already posted something. It's about the instructions about how to sign up in the event, but we're going to go through that later. So we know that this is a virtual event, and I don't know, virtual events are great, and I'm still so excited that we're able to still have this Cloud Study Jam, but what I kind of miss about in-person events and even lectures and stuff like that, it's if you're kind of lost, you can always like ask the person beside you, like, hey, what did he say? Or I didn't get that. If you have a quick bug or something, they can help you out. So to kind of simulate that, this is totally optional, but it's pretty cool. You can click, see this code with buddies. So you can click here, 2 people, 5 people, no limit. And if you click it, it'll put you in a new voice channel. Then you can just chat with your friends or meet new people. It's totally up to you how you want to do it. We just wanted to have this option to try to make this more collaborative. So another thing that's really important here is that this help room. So whenever we are not presenting, like I'm presenting right now, and Kathy and Shardul are available as mentors. So if you click here for help. You see it, let me leave it so there's no echo, but if you saw it created a new voice channel with just me in it, yeah, so Shardul is there. And it raises your hand saying like, oh, hey, I need some help, or you can join the chat room that's already created with Shardul, and this is Kathy here. So if you need help on anything during the Quicklabs, feel free to join here. And this is a lot easier than just like sending screenshots and stuff, because on Discord, you can share your screen and your mentor can look over what you're doing and guide you through it. So this is the study. This is the Study Jam channel. Yeah, if you have any questions, just post here and we'll monitor this chat. As well as Shardul or Kathy, just feel free to interrupt me if there's any questions that I'm not seeing while I present. So, all right, let's go back to the slides here. I just have too many tabs open. Just something also to mention. So there's online support within Quicklabs. Kathy's done it before. There's just a button in the top, right, that you click for support. Is that right, Kathy?
Yes. So at the top right, where your profile, like little badge is, there's a little button that has a drop-down menu. And so the chat support is the quickest way to get help in our experience. So if you experience any technical issues, just feel free to do that, or you can reach out to us on the Discord and we'll help you through it as well.
Yeah, absolutely. And then if there's like, this is probably for like after the event, you can email support@quicklabs.com and their team responds pretty quickly. I've chatted with them before. They're really helpful there. Awesome. So just an overview of what this event is. So what we're doing today is a Cloud Study Jam. So Pretty much what it is, especially this Cloud Study Jam. You get to learn the fundamentals of Google Cloud Platform. You get to learn how to run containers on it and potentially use for some data engineering, like load balancing things as well. So how long does it take? This one specifically is a virtual session. It's approximately 4 hours, but I personally think it'll be quite shorter than that. And the end result of this is that you get a badge. It's kind of like a virtual sticker kind of thing. And it shows up on your Quicklabs profile. You can add it to your resume, and I'll also show you how to add it to your LinkedIn at the end. And you get up to 2 months free access of Quicklabs. So today we're just doing one quest within Quicklabs, but there are, I don't know how many, definitely over 100 different labs that you can go through, and you get unlimited access to that for 2 months if you complete this today. So if that's not incentive, I don't know what is. It's a pretty good deal for you guys. All right, so let's get started. This is a video, just kind of, it'll go over what this study jam is about. It's only like 30 seconds long. It would play in the browser, but that's okay.
Get ready for a cloud-first workplace. Jumpstart your career by signing up for a Google Cloud hands-on learning experience. Companies around the
Is it loading for you guys as well?
If it's not working, we can kind of just
Yeah. So I thought this would.
are moving to the cloud.
Okay.
This is a unique opportunity to gain new.
Okay. Sorry about that. Usually it plays in the presentation. I think it's not working today. So basically, it's just this cloud study jam will get you ready to work with cloud in the workplace or even on your own projects, which I have some examples of coming up. So yeah, this basically will prepare you for cloud careers. And I really like this quote in here. So university education provides a strong theoretical foundation, and you need strong industry skills to launch your careers. So obviously all the courses you take in school gives you that theoretical knowledge. And we're here to hopefully bridge that gap so you can launch your career with some actual industry knowledge, which you probably will not have learned in school. So yeah, so this says, yeah, I really like this flowchart. Cloud study jams can get you career readiness, which you can use in competitions such as hackathons, internships, even your first job. And even if you've had jobs before, jobs in the future, you'll likely come across cloud one way or another. Oh, and this is the badge that you get at the end, this GCP Essentials, and it can show you, this is your profile, and all of your badges show up there. Yeah, so go cloud. So who uses Google Cloud? And the answer is lots of different companies. So a lot of these big names that pop out to me right away, like PayPal, Twitter, P&G, UPS, Home Depot even. So if you think about Twitter, think how massive it is. Think about how many users they have, how many tweets per day, managing all of those servers. Google Cloud helps with a lot of that. And a couple shout outs, they weren't on this list. This list was actually from Google's actual page. So some other companies that use cloud, maybe not specifically Google Cloud, but cloud in general, that are from Canada is Loblaws, RBC, and Rogers. So just to give a shout out to them as well, using this innovative technology. Also, I wanted to share some of my personal experiences with Google Cloud. So I used Google Cloud first in a hackathon. It was actually my first time ever using the Google Cloud platform. So if you see this image on the left here, you probably won't know what it is by a first look, but it's actually an automatic sorting garbage can. So you would take like a water bottle or something, you would put it in that slot. A Raspberry Pi takes a picture of it, and this is where it uses Google Cloud Platform. So it uses the Google Vision API. It's really simple to use, like it's only a couple lines of code in Python. But what it does, it takes the image, it analyzes it, it tells you what's in the image. So in our case, be like a water bottle or like a chips bag or something. And then our program would say, oh, it's a water bottle, that means it's recycling. So the platform would rotate to the recycling side and the bottle would fall in. And if not, if it would be garbage, it would rotate to the other side and it would fall in the garbage side. So this is what we made for our hackathon. And we actually won a prize, a sponsored prize for the best use of IoT. I'm also extending the same idea for a capstone final presentation. So I don't know about you guys, but in my last year of university, we do a year-long project. And we chose to improve this hackathon idea and make it a more, like not out of cardboard, I have actual materials. So this is what we have so far. It's not finished yet, but you place your garbage on this platform. Similar thing, this camera takes a picture, analyzes, and instead of the platform rotating, it's this pipe that rotates, and it can direct the garbage or recycling to where it needs to go. So we're using Google Cloud in the same way with that Vision API. As well as we extended it to have even a front end. So this is an app that you have that connects right to this device here. So when the Raspberry Pi takes a picture, it uploads to Google Firebase storage. Obviously, this is a temporary picture, like the camera did not take this, but it uploads to the cloud, and right away live, you get the updates in your app if you have it open. So that's just my personal experience of using Google Cloud. So let's get into the more details of what exactly is cloud, and like what are the different services it can offer, and like how could I use it personally. So first of all, there are three main types of cloud-based services. So the first one is infrastructure as a service, platform as a service, and software as a service. So the key thing here is this add as a service part. So if you think about, say you wanted to host your own database, all of the things that you would need. Well, let's go even further. Say you want to host a web server. So first of all, you're going to need hardware to run that server on, right? And then you probably need a platform after you install all your libraries and stuff. And if you're providing a service to someone, it's another layer even on top of that. So Google Cloud helps, you can pick like infrastructure, platform, or software as a service, depending on what you need. And it manages all of those things in the background for you. So the first one is infrastructure as a service. So this includes all of the raw resources, such as virtual machines, networking, and storage. So this is services that Google provides. They're pretty much like the fundamental blocks of cloud computing. So when you get an infrastructure as a service from your cloud provider, you have a lot more overhead of what you can do because you yourself have to install upgrades, patch all the software required to run your application. But the hardware is actually owned by Google and runs on the Google server farms. So just an example of I guess you probably wouldn't know, but later we're going to go through Compute Engine, and that's an example of infrastructure as a service. So the next one is platform as a service. So This provides you with managed services in a runtime environment where a lot of things are pre-configured. For example, like networking is pre-configured. It often comes with runtimes pre-installed. Load balancers can be set up for you already. And all of these upgrades and patches are done automatically. So pretty much you just have to manage your application and what it does, and all of this other things like configuring the runtime and managing it is done for you. So I know that's pretty cool. And the last one is software as a service. So this is an entire application that's already managed for you, and the only interaction that you do with it is use it, literally. So the common example of software as a service is Gmail. So all you have to do, like you create your Gmail account. I think that's all the setup you ever have to do. From then on, you just use the service. You don't have to worry about what platform it runs on. You don't have to worry about where it's running, anything. All you do is use it. So yeah, this slide sums up a lot of things. So no need to manage your own infrastructure. Use managed services instead. So you can do lots of different things like store objects like files in the cloud. That's what I'm doing for my app, for my capstone project. Like we upload that image file. You can manage high volume data streaming or gaming data. Pokemon Go is a good example of that. You know, back when it was really popular, had lots of high volume, and it was powered by Google Cloud, so that's how it was able to keep up. As well as database data, application logic, and it's easy to integrate with other Google services, such as Google Maps or YouTube APIs and so forth. Yeah, so overall, it's using the power of cloud. You can take your app global in minutes. So just to think about how much work it would have you, it would take a lot of work to deploy your own application worldwide and have everyone around the world have the same latency. If a server goes down, what happens? You have to manage that yourself. But with Google Cloud, all of this is done for you. Like if you just want to think about all of the services that Google has, they honestly have atomic clocks within their databases. Inside the servers, they use the atomic clocks to synchronize databases around the world. They also have dedicated fiber with dedicated network applications. So you're not using other people's, you're not impacted by other people's internet traffic. Google has their own dedicated mediums for that. If you think about how if you were able to do this on your own, you would need millions and millions of dollars, definitely. But with Google Cloud, all you have to do is, most things are just pay as you go, and you only pay with what you need. So has really amazing capabilities. All right, so that's a little intro to cloud. I don't know, I'm not monitoring the YouTube live or Discord right now. Do we have any questions at the time? Maybe Shardul or Shashank could let me know.
We're okay for now.
I think we're good.
Okay, awesome. So yeah, and like any questions, honestly, let me know if you just want to chat. Even after the workshop, I'd be happy to chat about cloud or anything related to it. Okay, so now we're going to go into the actual Quicklab and getting it set up. So what you will need is a Quicklabs account. If you already have a Quicklabs account, make sure you are unenrolled from this quest that we're going to go through if you are already. So I'm going to go through how to get you guys set up. But just, yeah, some other information, you can contact support@quicklabs.com in case you're having any issues, as well as that live chat. So this is what you guys will need to follow. So first of all, you need to open an incognito window to do this. So it'll still work if it's not an incognito window, although it gets really frustrating because basically what Quicklabs does for each lab, it gives you like a temporary Google account that only exists during this lab. So if you see, I don't know, in my Google account, I forgot to use incognito tabs, and now when I'm prompted to log in, it has all of these Quicklabs accounts. So make sure you do the incognito window. I already have it set up, so I won't be going through the whole process, but I will show you how to find, how to go to this link and what to do from there. So I don't think I can copy from a slide. I think I have to exit presenter view just for a second.
Just to quickly chime in here, the instructions are also posted on the events Discord. So if you need the link and also the code, you can go visit the Cloud Study Jam channel. Maybe Miranda, you can just quickly show the Discord too.
Yeah, for sure. So if you see this Cloud Study Jam channel, yeah, you posted this here, Shardul, right? This is the instructions, yeah. So that's just a summary of the screenshot that I posted. So yeah, I'll also go through this with you right now too, so you'll be able to see. Okay, so open an incognito window and go to this website. So that link is in the Discord channel. Could you post it in the in the YouTube live channel as well?
Yep.
Awesome, thanks. So for some reason, this site is really slow. So you have to access the lab through this site. If you Google Quicklabs Essentials, you won't be prompted to enter the code and you won't get your free credits that way. So once this finally loads, this is the one we wanted to click on. There should be an enroll button that will pop up soon. Eventually. Okay, maybe it won't work for me. Oh, never mind. Okay, so once you scroll past all of this stuff and go to this GCP Essentials, this is the quest that we're going to go through today. So once you click enroll, it will prompt you for the access code. So the access code is in the Discord as well. It is this code here. So, excuse me, 1S Ontario 4978. And if you don't have a Quicklabs account, you're able to create one now. And because it's incognito, you probably will be logged out. So once you enter the code, then log back in and click enroll. Okay, so what this code does, once you enter the code, it'll give you 5 Quicklab credits right away. So usually you need Quicklab credits to actually go through the labs. But in our case, this code automatically gives you 5 credits. And once you complete the first lab, it gives you an entire month for free. So that's what this code does. This code only works today, unfortunately. So if you're watching it a bit later, you're going to need your own way to get some credits. So after, you get 1 month after you complete the first lab. And if you complete the entire quest that we're going to go through today, you again get a second month of free access to Quicklabs. So make sure you go to this link here. Click enroll, get prompted for that code, enter it. And Shardul, I remember you had some issues when you were trying this before. Do you want to just talk a bit about what you did to fix it?
Yeah, sure. So when you go ahead and enter the access code, it's going to enroll you automatically. And then you need to sign in. You might not receive the 5 credits right away. So what you need to do is unenroll and try to enroll back again. And you should be able to get those 5 credits. To make sure that you get those 5 credits, you can click on your profile and it should show, maybe Miranda, you can show this. It will show in little like green text that you have a certain number of credits.
Yeah, right here. So I have this many credits. It should show up that you have 5 credits at least. Okay, cool. Thanks, Shardul. So if you have any trouble with this setup, feel free to like ask in either the Discord, the YouTube live chat, or enter those help rooms. Because this part is pretty crucial for going through the actual lab. I think do you think I should give a minute or two, or do you think everyone's set up already?
Yeah, we can wait for people to verify that they've successfully gotten the 5 credits, and then we can go through the first lab.
Sounds good. So the first lab is free. I think after that, the labs are between 1 and 5 credits each. But you will have that 1 month free access after you complete that first lab. So sounds good. Could you just let me know when some people say that they're all set up? Maybe in the YouTube live, you can leave a comment, or in the Discord as well. That works too. Oh, wait just another minute or two. Yeah, and if you have any questions or it's not working for you for some reason, just let us know and we can help you out for sure.
I think maybe, Miranda, we can even just kind of go into introducing the first lab while, excuse me, while people are kind of setting things up.
Yeah, that's a good idea. So the labs are very like they're supposed to be self-paced, so they honestly tell you everything that you need to know. I prepared some slides just before the lab, just to give like a quick overview of what we're going to talk about. So yeah, good idea. I can go through that for now. Okay, yeah. So the first lab that I'm going to go through, it's a tour of Quicklabs and the Google Clouds. Excuse me, the Google Cloud Platform. So if you ever see GCP, that stands for Google Cloud Platform. And what we're going to go through is the Google Cloud Console, as well as just kind of learn about how Quicklabs work. It takes a bit to, well, I'll show you later. There's instructions, like specific instructions you have to follow to start the lab, but it's not too confusing. So just a quick overview of what we're going to talk about in the lab. One of the things that we talk about is Google Cloud projects. So all Google services that you use are associated with a specific project. So this is kind of separates like different things. So for example, I have a project for my for the hackathon that I did in GCP, and I also have another project dedicated to my capstone final project. So they're separate from each other. They're separate resources, like the separate billing if I were going to use the paid services. And that's what we're going to, I believe that we use one project per lab for this, but just to be aware, there's things that exist as projects and they're quite separate. Another thing that is important in GCP is this Google Cloud Identity Access Management. So it's IAM for short. So there are so many different services within the Google Cloud platform that we're going to see when we go through the lab. And IAM allows you to specify like who's allowed to do what on which resource. That's exactly what it is. So if you say I'm the admin, I can do everything. Say you were selling your services to someone else, and they're only allowed to read it. They can't delete your servers or do anything like that. So this is just another way of separating responsibility and who's allowed to do what. Okay, so how's it going so far? Do we have any questions or people set up on the lab? Do we have any responses on the YouTube Live or Discord?
Yeah, there's a few people who have said they're okay in the Discord and one person who's okay in the YouTube. So I think we're okay.
Oh, awesome. Cool. So I think we're ready to get started now. So if you click a tour, this is the first lab that we're going to go through. So click this and we're going to go through it together. Yeah, that's the end of the slides for this. And let me pull up this lab. You can see this, right? Like it's not, I wasn't just sharing my one window.
Yeah, you're good, Miranda.
Awesome, thank you. Yeah, so this is, so once you click on it, don't click start yet because a timer starts, and once that timer is done, like, well, this lab is free, but technically you would have to pay a credit to do the lab again. So yeah, let's start at the beginning. So Google Cloud is a suite of cloud services on Google's infrastructure. So there's lots of different things such as computing, storage, data analytics, machine learning, APIs that can be used in any cloud computing project, all the way from personal to enterprise grade. So you can be like me, use it for your capstone, and then you can also apply it in the industry. So if you want to work at Twitter or any of the big companies like that working on the cloud side, Google allows you to do this. So yeah, this just kind of gives a summary of the lab. We get to go through the Cloud Console, which is a user interface browser that lets you manage all of the Google Cloud services. So there are 3 different ways that you can create services and basically use the GCP platform. So the first way is through this console, which we're going to show you. It's like a user interface. You can click on like what VM you want, everything like that. The second way is that there's a built-in shell in the Google Cloud platform. And this is like a Linux terminal that you can type and use, interact with all of the services that way. And the third way is you can download the SDK, software development kit, on your own computer and go from there. So we're going to go through 2 of these in detail in this Quicklabs, so just to give you like kind of an overview. So in this first lab, we're just going to learn about the Quicklabs platform, how to use this platform. Then we're going to look at the Google Cloud Console, and we're going to talk about the projects and IAM that we talked about before, as well as explore some of its APIs. So yeah, this is a very introductory lab. It assumes that you're unfamiliar with GCP as well as Quicklabs, so we're going to cover everything for you. Okay, so first of all, a lot of you may already have a Google account. So if you have a Google account, this is not, so you're able to log into the Google Cloud platform with your own Google account. Like that's what I do for all of my projects and stuff. So if you have a Google account, make sure you don't use that for these labs because this Quicklab like boots up services just temporarily, and like if you run this on your own stuff, you could be charged money, and that's real money, not Quicklab credits. So just make a note of that. Okay, so just to talk about the Quicklabs. So to actually start the lab, this is the button, and then the timer starts counting down, and that's how much time you have to complete this lab. So the time that they give is quite generous. I don't think we're going to get close to the end of it within this lab, but just to be aware that this timer exists, and when it ends, you won't be able to access what you've been working on so far. Yeah, so there's also like a score. Usually it shows up in this top right here. It shows like out of 100 how much you've completed the lab. And to like get a check mark and complete this lab, it needs to be at 100%. So some labs are free, such as this one. This goes into how to buy credits. We don't need to worry about that for this lab, because hopefully you guys all have that 1 month free access now, as well as 5 additional credits. So that's very generous that they're able to give that to you guys. And yeah, all of the instructions are here. I have 2 monitors right now. I will do my best to have both things open on one monitor so I can share it with you guys, but it's easy to separate in different tabs as well. So I don't know, if I was in person, I think I would ask someone, but I think I'm just going to go through these questions as well. I think you guys can go through it as well. I think it's part of the score actually for this lab. So, oh, I can't do the questions because I haven't started the lab yet. So what you guys can do this as well. Click this start lab. Say you're not a robot unless you are, then don't click that. Okay, awesome. So now see the timer starts this end lab, but don't click this end lab. It won't pause, it'll actually stop everything. So this builds a temporary environment in Google Cloud. That is the start button. So let's see. Yep, that's right. So when the timer reaches 0, you will lose access to your temporary Google Cloud environment. That is true. So once this is done, they give you like a temporary Google account, yeah, at quicklabs.net. So even this, you won't be able to access this at all. Okay, and some labs have tracking which scores your completion of hands-on lab activities. That's true as well. So you'll see in some later labs that there's some buttons that you click, it says like check your progress. And it actually goes into the Google Cloud platform, make sure you've created the things that you need to for the lab. And in order to receive completion of the lab credit, you must complete all required hands-on activities. That's true as well. They almost tricked me. They switched the position of true and false. Yes, that's right. Cool. So, oh, now it tells you to start the lab, but I guess you guys have all done that already. That's fine. Yeah, another note, don't click end lab until you completed all of them, because then you have to use a credit or something to start the lab again. Usually, but in your case it's free, so I guess it's okay, but still don't click it. So this is the panel here that you're going to use for every lab. So this username is like a temporary email that you create that's created for you. This is what you're going to use to log into the Google Cloud Platform console. And this is the password they give you, and this is the project ID. This is the project, like I mentioned before, projects are like separate things. So this is the project ID that you're going to be working on for this lab only. Another thing to mention is that each lab, you have to do this, repeat this whole process again. So it might be a bit confusing the first time. After all 5 labs, you'll breeze through this part. So you click this button, open Google Console. It'll open the console in a new tab. Yeah, so I forgot to do this in an incognito window. If you see all of this Quicklabs stuff here, I'm just going to continue on this because I already have it set up, but you should definitely use a incognito window. So you click the bottom. Even if you have your own email and stuff, don't do it. Click sign into a new account. You have this username here. Click this button. It'll copy it to your clipboard. Then you can paste it in here. Next is the password. And you same thing. You just click this button to copy it to your clipboard. Awesome. So, yeah, it pretends it like it's a new account. It's just technically a temporary account. So don't set up this at all because this is literally just for this specific lab and it won't exist like in 20 minutes when we finish this. So awesome. So now you're logged in. Let me go back to here, just make sure I didn't miss anything. Yeah, so this, in case you miss anything that I went through, this lab also tells you how to sign in, make sure you use the other account. Okay, and we can do this quiz before we move on. So what field is not found in the left plane? That's this left plane right here. So password is there. This is here, project ID, system admin. I don't even know. That's definitely not there. So go. The username in the left panel, which resembles this, Quicklabs.net, is a cloud IAM identity. That is true. So if you remember in the slides, I talked about IAM. It's it also is in charge of like identifying you. So this is you, like as for this lab, and all the permissions are set through this Quicklabs.net. So now that we're signed into the cloud console, I'll just make sure I went through. Yep, I'm signed in. So now we'll be able to look at everything on here. So honestly, this, oh yeah, make sure you agree to the terms and conditions and don't click this because you won't even be able to log into this account. So, awesome. So once you've got into this console, this is the first thing that you see. So it might be overwhelming, you know, there's so many things on here, but we're gonna go through them one at a time. So I'm gonna see if I can open the console as well as the lab in the same window. Just bear with me if it doesn't look so nice for 1 second. Okay. Wow, this this does not work at all. Let me zoom out a bit. Could someone tell me if this looks okay for now? Or does it look so bad and I should just switch between the tabs? What do you think?
You look like you're okay. Oh, sorry.
Yeah, that looks
okay. Awesome, awesome. Okay, cool. So some things are cut off here. I guess I can move it a bit once I want to show you. So like I mentioned before in the slides, it just talks about like what a project ID is. So if you see this, if it makes my window bigger, yeah, this project info right here. So this is the project name. Every project has a name. I think an ID in this case it's same, but within your account, the project name can be whatever you want, but I believe the project ID has to be unique. Like it's unique globally. So it's globally identifiable that way. So just to keep that in mind for when you're making your labs, making projects in the future in your own account. Like I think test 1, 2, 3, test 1, 2, 3, 4, like all of that stuff is taken already, of course, but they can help you generate some IDs. Okay, so back to here. Oh, this is what we've already gone through already. Sorry, it skipped a lot, but at least you can see in the console where the project ID is. Okay, so here in the console, you can click on this name, and you see this is your projects here. If you go to all, these are all of the projects that are created, but it's just for this lab, this won't exist after the lab. So including Quicklab resources. So first of all, don't switch that you're on this project right now. Don't switch any. This is just how you can see all of your projects. And it's not uncommon for large enterprises to have multiple projects for different teams, different apps, things like that. Like I told you before, I have one for Capstone and one for each hackathon I've went to. So that's how you navigate between different projects. Just click cancel for now. Yeah, so this Quicklabs resources project that was there, this is a read-only one. It's just in Quicklabs. And right, we can do this quiz now. I hate when it's so squished like that. Okay. Oh, and it messed up where it was too. Okay, here's where we are. So an organizing entity for anything you build within Google Cloud project. Google Cloud, oh no, I gave away the answer in the question. It is Google Cloud project. And Quicklabs resources is a shared read-only with all Quicklab users, which means you cannot delete or modify it. That is true. That's that Quicklabs resources that you saw in there. And the Quicklabs resources is where you run all of your lab steps. So I believe this one is false. Let me just make sure. Okay, good. Yeah, so you run all of your labs and stuff in the project that has this ID. The Quicklabs resources is just for reference material, and you can use to look at it. All right, so next we're going to explore the navigation panel. Oh, man. Bear with me for a second. Okay, so next we're going to go through the navigation menu and all of its services here. So if you click this thing, oh, I should have made it go away before. That's fine. Click this to open it if it's not already open. And you can scroll through all of these services here. So this looks like a lot. Honestly, because it is a lot, but there's each thing has a specific use. So under compute, this is all your VMs, stuff like that. If you want to run containers or serverless functions, this is where the category for that is. Storage down here, file store, you can store, create databases that way, or databases is down here. You can create databases. This is for uploading objects. An object is it's basically like a Google Drive. So I actually use this file store when in my Capstone application, when that Raspberry Pi takes a picture and uploads it to the file store, which then my app grabs from and loads it from there. So that's how I'd access this. All your databases here. Networking, so to set up virtual private clouds. We're going to get a bit more into a bit of at least the computing a bit later. This is just to give you a brief overview. Feel free on your own time to go and look at things. But actually a good point I forgot to mention before. So if you try to create things on this account, I actually don't think you create anything in this lab. If you try on your own to create a VM or lots of VMs or something, Quicklabs can lock you out. Kathy, you had an experience with that, right? How did you overcome that?
Yeah, so just keep in mind during these labs, I think they're quite, they restrict you to what you can do. So, for example, I was setting up, I think it wanted me to set up 3 VMs and then I messed one up. So I went back and deleted and then reset that. So Quicklabs locked me out. So in case that happens, you see up there near Miranda's picture, the profile button, there's that question mark. So if you click that, that's the chat support. So just they respond really quickly and they can get you back in. Just keep that in mind though. If you do stray too far away from the lab, you will lose the progress. So try not to. On your own time after the quest is done, then you can go ahead and explore all you need. But just for the sake of the labs and so we don't end up with any complications, just try and stick to what the lab does. But that's about it. Yeah, go ahead.
Yeah, absolutely. Thanks, Kathy. So that's a good point to mention. Yeah, honestly, on your own, you can explore all of these things, but for this, like, we're gonna try to stick to what the lab has us to do. So yeah, these are just all the other services. There's operations. If you want to see monitoring or logging, you can actually monitor by how much things are costing you. So I remember I set up an alarm that if it goes over $1, like send me spam my email because I don't want to spend money on Google Cloud platform. I don't want to wake up with a bill in the morning. There's a way you can even like shut things down if they reach a certain limit that way too. All of these different tools. These tools kind of just help with deployment mostly. So you can help deploy your applications on here, API gateways. If you have like a full stack application, I think you would use this, but it's probably more used in industry as well. Have all your big data functions here. AI stuff. I think AI is one of the platforms that GCP has is one of its most impressive services, probably next to its scaling databases. But I don't know, you can explore these on your own. This is just an overview of what everything has now. And yeah, there's links inside this lab that tells you everything as well. Okay, so task 3 is viewing your roles and permissions. So in that slide before, as well as services, there's also IAM, Identity Access Management, which tells you like, yeah, who can do what on which resource. So let's view that within the console. So on the navigation menu, we're going to go to IAM, and I think we just click this. We don't click anything that the menu pops up. Yeah, that's right. Okay, so this is all the services. All of the accounts that have access to different services. So if you see, these are all stuff that are automatically set up with Quicklabs. This is me. Yeah, this 0088. Yeah, so you can see yourself. We have editor role, so that's pretty much you can do anything. So you can access all of the services, you can delete things, modify it. Yeah, so I think it talks about the different roles here as well. Yeah, so there's 3 different roles, main roles at least, and they all have different permissions. So if you wanted to create a new account just to view it, you can set it to this role. Editor can do everything except the exclusive thing that owner can do that editor can't do is set up billing for a project. So to actually even access specific services, not within this lab, but like on your own, I believe it's to even set up a VM, you have to enable billing on your account just in case you go over the quota limits of the free tier. Okay, so now there's another quiz. We're almost done this part, by the way. Then you can get your hands, yeah, the next part's pretty fun. Okay, so what offers you access to the platform services and outlines all its offerings? That is the navigation menu. These are things that are inside of the navigation menu. So primitive rules set up level permissions and unless otherwise specified, control access management and to all Google Cloud services. That is true. So those rules that you set specify what you can and cannot do. So provides all viewer permissions plus permissions that modify state, and you can change. So that's the editor role. Awesome. So something that's really cool on GCP as well as all of its APIs and services. So yeah, Google Cloud has over 200 APIs. They range, from all business administration to machine learning. That API that I used in my hackathon and capstone project is the Vision API. So task 4 is to view the available APIs. So on this navigation menu again, we're going to go to API and services. So let's just find that here. Did I pass it? I think I did. Yeah. So it's right at the top here. So you go here and then library. So yeah, there's over 200 APIs, like I said. So you can sort them by what you want. This lab has us enable the dialog flow API. So it's actually right here. You can search it as well if it's not here for you. So let's click on this dialog flow API. And this allows you to have like conversations, like for example, Google Assistant, and you don't really have to have any knowledge of machine learning to use this. Super cool. So by default, all of the APIs are disabled. That's just so there can't be anything happening that you don't know about. So click enable. It usually takes a couple seconds or maybe a minute. So whenever you need to have an API, like there's times I've tried to use APIs and it says, oh, this is not enabled. I just have to go and click this enable button. Awesome. So this is the overview of, like its traffic response and stuff. If you want, you can click try this API. It opens up just the documentation about it. You can read on your own time. I'm not going to go through now just because I'm seeing this clock here and I said it'll be done in around half of it. So let's keep going for now. But that's how you access any APIs. And Google has really good documentation on how to utilize the API and like tons of different applications as well. So there's lots of resources out there. Okay, when you start a lab in Quicklabs, you need to enable the APIs in the project to start working with Google Cloud. That is true. And they're all disabled by default. So, oh my God, wait. Okay. I didn't understand the question all the way. So when you start a lab in Quicklabs, they are actually already enabled for you if you're going to use APIs within the lab. But when you start your own project on your own, then you need to enable it because they're disabled by default. I'm sorry, I got one wrong. There's no penalty, but yeah. All right, so the last thing that we're going to go through in this lab is the Cloud Shell. So within this, remember I mentioned before there's 3 different ways to interact with all of Google Cloud services. So the first one is this console with everything on here. And the second one that we're going to go through in this lab is the Cloud Shell. So to work with the Cloud Shell, that's better actually. So you're just going to see this button, Activate Cloud Shell, in the top corner. It looks like this. So click on it and the shell should pop up in the bottom. Click Continue. It's free to use. You don't need to enable billing or anything to use it. So this is I really like this shell because you don't need to run a shell on your own computer and set up and provision all of the SDKs and all of the permissions and stuff like that. I don't know if you've ever had to work on about it on your own, but it gets complicated. So to avoid all of that, this shell is built in and has access to all your services right here. And this is actually like a Linux machine, and it's persistent. So if you create a file or something and then you log out and log back into the same account, obviously we can't on this Quicklabs, but on your own account, all of this stuff that you created will still be there. So to just authorize, type in gcloud auth list, and then something should pop up. Yep. It's requesting your credentials to make a GCP API call. Just click authorize just to activate the shell. So once you see this, once you run that, you should see this set up here. And yeah, this gcloud command, this is how you interact with all of the Google Cloud services using this built-in command called gcloud. So if you have some familiarity with Linux, then this part should not be so bad for you. But even if not, we're going to just do some basic like file creation inside of here. So this is not on your own computer or anything. This is a instance like inside Google Cloud. It's how you can relate to all of your services as well. So let's type touch. Test.txt. Touch creates a file. So we're creating a file called test.txt. Man, that's a tongue twister. So ls just lists all of the files. And if you see there's two files, one of them being the one we just created. So nano is a text editor. We're just going to add a basic line to this, this file. So nano test.txt. Okay, so now we're inside the file. We're going to edit it. Tells you to write Google Cloud and Quicklabs are the best. I'm just going to write DSC. Are the best. Quicklabs is the best as well, so don't get me wrong. So if you see all these shortcuts down here, this is kind of like a remind you of how to write and stuff because there's no save button or anything. So once you've typed whatever you want to type, press Control, and then it saves automatically. Then Control X. So it says save, yes, no, click yes. So press Y. File name to write test.txt. Yep, that's right. So press enter, and it'll go back, make you go back to this shell here. Another command that we're going to use is cat. This just reads the output of a file, just to show you that we saved it properly. I'm pretty sure that we did. So if we do cat test.txt, there we go. It prints out the message that Google Cloud and DSC and also Quicklabs are the best. Awesome. So that concludes the end of this first lab. And hopefully you're now familiar with the Google Cloud console as well as a bit of the shell as well. Before I end the lab, does anyone have any questions or they're stuck on anything specific? Just let me know in the YouTube live or the Discord, and then when another one of the mentors can let me know. Okay, I'm not hearing anything. So Shardul and Kathy, do you think I'm ready to end this lab then?
Looks like, yeah, we can move on.
Yeah,
awesome.
Just to mention, if you have any questions or problems with getting the monthly subscription, you can also join our help channel that Miranda went over. We also have one of our mentors, Christy, just looking over that, and she's going to join and help you guys if you have any problems.
All right, yeah, so thank you. Yeah, so once we're done this, you can exit this Google Cloud Platform console. We are going to use it in every lab, but we're going to go through that whole process of logging in again separately for each lab because it keeps all their resources separate. And you can do them like on your own time too, if you like. So close that window. That's fine. It won't be saved. And we're going to click End Lab, and all of the things that we are done, that we did, are going to disappear in the console, but that's okay because it's just about learning today. So click End Lab. Okay. 5 stars. Yeah, I liked it. I felt like it was a really good introduction. Awesome. So I've already done all of this lab, all of this quest, but if you press the back button, you should see this green check mark next to the tour of Quicklabs and Google Cloud, because that's the lab that we just completed. Awesome. So since I've been talking, which over an hour now, which feels like so long, I'm going to pass it off to Kathy, the DSC lead from Ryerson, and she's going to go through the next 2 labs with you, as well as share some slides. So Kathy, are you ready if I stop sharing my screen?
Yeah, of course. Go right ahead.
Awesome. Thank you very much.
Okay, so just give me 1 second to share my screen with everybody. Okay, so it should be okay. Can you give me some feedback?
Yep, that looks good.
Okay, awesome. So, okay. Great. So we're going to take a look at virtual machines. So let me just go to, great. Yeah, so virtual machines are exactly kind of what they say they are in the name. It's a machine that you set up, but it's virtual. So it acts just like your physical computer would. So you allocate whatever resources you want. So for example, you can define what kind of CPU you want, memory capacity, even the OS that your virtual machine is running. So it does use the physical resources of whatever server farm that it's on, but you as the user define what you want your machine to have. So just like the specs on a computer, you're going to define that for your virtual machine. So the best thing about virtual machines, they on top of having the same functionality as physical hardware, they also are portable, easier to manage, and better for security. So each time you launch a virtual machine, it you can run your applications, do whatever you need. It can even, you can change your data and then destroy the virtual machine, and then all of your, your data and everything still persists. So we're actually going to talk about that in more depth. But firstly, your virtual machines are you have to tell them where they are. So the first thing you define is the region. So each of these regions, Western US, Central US, these are all separate regions, and they're independent of each other. So each of these regions are then divided into zones. So US West 1A and then US West 1B. So, and then these zones are also independent of each other. So we're going to talk about this quite a bit as we move forward, but there's quite a bit of redundancy in this, using this, because it's part of the reliability factor. So for example, if you deploy across multiple zones, then for example, if US West 1A goes down, then you still have B to power whatever you need to. So this shouldn't be too hard to grasp, so I'm going to move on. Great. So you can kind of choose what you need. So we're going to go over the compute engine that's within the Google Cloud platform. And that's what, as Miranda said, that's where all the virtual machines are going to be sort of handled. So the first point is pretty self-explanatory. The second part, persistent disks, might be a new term. So they are essentially as they call it, durable network storage devices. So they're accessed just like regular storage disks are so you can access it using your virtual machine. And they are redundantly stored, so that increases their durability. So again, with the redundancy, if something goes down, you still have this information stored redundantly in another place. So the reason why they're persistent disks is because they're actually independent of your virtual machine. So the way that our computers are set up, we have our disks associated with our machines, right? But with a virtual machine, you can sort of instantiate this virtual machine, have it talk to the persistent disk, and then change or add, delete data as you need. And then once you close off your virtual machine, that disk still persists. So hence the term. All these other things we'll kind of go through as we move along the lab. So the point of Lab 2 is to, one, create a virtual machine through two ways. One is using the platform that Miranda had just showed you. So you can use it you can do it using the GUI, or you can do it using the Qcloud command line. So we're going to go through that. And once we have a virtual machine, we're also going to we're going to deploy the Nginx web server, and that's going to connect to your virtual machine. And that's how, everyone else is going to be able to sort of pass along requests to your machine. So we're going to go through this, and I'm going to pull up this now. So I actually, I used a separate email, so I should be doing exactly what you're doing now. Yes. Great, so we're going to launch this. The beginning of this lab is exactly the same as what Miranda went through. So all of this stuff is exactly the same. So we're going to start the lab. Oops. Can I move this? Great, so okay, so we're going to open the Google console, and it's going to do the same thing. I forgot to do it in Incognito, so I have the same issue with all those kind of dummy accounts. So we're going to copy this, paste this into here, go next, copy the password, put the password in. So again, this is that temporary account that we're going to create. And unfortunately, we have to do this every time because each lab creates a new session for you. So yeah, you're going to get real good with this. Okay, so that's going to move forward. So I'm going to pull this out. I hope you're still able to see everything okay. So again, we're going to agree to the terms of services. Please move this window away from. I'm sorry, I don't know why it's not responding. Okay. Okay, there we go. Yeah, sorry about that. Actually, can Miranda or Shardul, can you tell me if I'm sharing my screen or my browser itself?
Right now I see the Google Cloud Console.
Oh, you do?
Yeah.
Okay, perfect. Then I'll just stay within this browser. So I'm going to go back here. Okay, so same deal. We're going to activate the Cloud Shell. Okay, great. So again, same deal. So I'm going to just kind of breeze through this. So we're going to go ahead, Qcloud auth list. We're going to authorize. Great. All right, so we went through those kind of the regions and the zones. So it's just kind of explaining that again. So this is, I think, where the fun part starts. Okay, so where all of your all of your VMs are going to be managed under your compute engine. So if you go into compute engine here, you can see your VM instances. Great. So we're going to hit create here. I'm going to minimize this just so it's easier to see, but we're going to create a VM instance. And for this, we're going to just stick with the specifications that they give us. So we're going to call it GCE Lab. We're going to define the region. So US Central 1, Iowa, great. US Central 1C, US Central 1C, great. Whoops. So if you take a look, this is kind of, you're seeing sort of the specifications of the machine that we're going to create. So this is a 2-core CPU with 7.5 gigs of RAM. So we're going to go ahead and select that. These are predefined here. So we're going to, whoopsies. Okay, there it is. So this is an N1 standard 2. So we're going to find that here. N1, just not here. Oh, sorry. Okay, so we're going to pick N1 here. So it's going to show us these. Great. So 2 cores, 7.5. Great. So let's see that we're setting up everything. So these are, so the one that we're going to work on, it defaults to, defaults to Debian. So let's just go ahead and make sure everything is right. Great. And firewall. So that's the last thing that we have to change. So just allow HTTP traffic, and that's going to allow us to actually send requests over. Great. So everything looks like it's right. If everyone else kind of has the same setup, then we can move forward. And we're going to create that. Great. So it takes a little bit for these to sort of get up and running. So while we wait for that to happen, the next thing we're going to do is SSH into the virtual machine. So that's going to show up when, perfect. Is it? No, it's still setting up. Great. So it actually takes care of everything for you. So as soon as you set this up, it has like a wrapper around it that Google Cloud takes care of for you. So you can directly just access it. Great. So we're going to connect to the SSH server. We're going to launch the SSH client. And once you hit the SSH here, it's going to bring up a prompt, and that's going to, bring up a new browser. So you guys can't actually see that. Let me change my screen share to share the entire thing. So just give me 1 second. Okay, so this is what you're going to see now. Let's pull that to the side. Oh, no, we can't. Okay. Great. So if you follow along, the first thing we're going to do is sudo su dash. So we're going to just go ahead and run the command. I'm going to copy and paste because my my typing skills are horrendous. So great. So really, you're just going to follow these commands. So the first command is going to get you into the root. You're going to run this apt get, and then it's going to give a bunch of stuff. So it's grabbing some packages, it's going to unpack, it's going to do all the things that it needs to do, and it'll take a little bit. So as you can see, it's done. Great. So now we're going to install Nginx. So apt get install Nginx-y.
Oh, hey, Kathy.
Yeah.
I'm sorry to interrupt. Are you trying to share both windows at the same time?
No, I'm just trying to show this screen. I can't If I try pulling this over, it just goes all funky, so I can't.
Oh, yeah, true.
Yeah.
I was having that issue too.
Otherwise, I can do this. Maybe that's helpful so that you can see exactly what's happening. So we've done this step, and we are currently on this step. Maybe that's a bit clearer. So I'll hit enter. So yeah, you can see it's preparing, unpacking. It's going to set up and then do all the installations for you. Great. So now that all that's done, we're going to check that Nginx is actually running. So we're going to check the processes. So I'm going to copy this. And it's going to grep for Nginx. So it's going to only show the processes that have something associated with Nginx. So right here, we see, great. So that means this line right here means that it is running. So that's going to show up right here. Great. So we are going to go back and to actually be able to see what is there right now, we want to access it using, we want to be able to access what's on the VM from an outside point. So we're going to need the external IP. So we are going to go back into our Google Cloud Platform, and you're going to take a look here. Now that Nginx is running, you'll be able to actually see this like pop out. That wasn't there before because we didn't actually connect it to any web server, so it wasn't visible from the outside. But now if you click that, it's going to show this. So this is kind of the web page that we were expecting. So that's awesome. This is the default web page. That's awesome. So far, if you have followed along, I hope I haven't gone too quickly. But if you, I guess in the chat, is there anything happening? If not, if you're at the same point, you should just be able to check my progress and it'll give you a nice check mark. Yeah, I guess it's smart that way and it can just go check. Okay, so that was creating it using the GUI. So what we're going to do now is actually create it using the Cloud Console. So if some of you are very, apt with Linux and those bash commands, then you'll be very comfortable doing this. If not, take a little bit of time to sort of review how the syntax and everything works, but it should be pretty straightforward, I think. So we are going to go back into the cloud platform and, oops, do I have something? Yes, I do have it open. Great. So this is really long, but basically it says gcloud compute instances. So this is the sort of the package, that all the commands under the SDK. It's going to say compute, so we're doing the compute engine instances of VMs, and we're going to create a new instance. So that's kind of how to decipher that. This parameter is going to be its name. This machine type is a flag, so you're going to say, okay, the machine type is going to be the N1 standard 2, which is exactly what we did using the GUI, and we're going to tell it to put it in the zone US Central C. So that's kind of how to read that command. So if you just copy this command into the Google Cloud, the Cloud Console, it should create a new instance, new VM instance called GCE Lab 2. So it does take a little bit. Don't be surprised if it's just kind of sitting there for a bit, but there it goes. Great. So now it's running. So this is the expected output. That's exactly what we got. And you can see how this sort of translates into this. So the name, zone, and then machine type was exactly what we defined it to be. So now that we're here, we're going to do a quick check my progress, which will be a good time for me to ask you guys about your progress as well. If there's any issues, feel free to pop it into the chat. In the meantime, I am going to check my progress and hopefully, yes, it passes. Okay. Everything looks good. Great. So these are just the, so like I said, it runs, excuse me. So these are the defaults. So we had specified this, but this is the default machine type. You can go ahead and try other ones. So this one for like processes or for an application that has high memory usage, you can, use this kind of machine type. For something very CPU intensive, then you can use this. So they have a lot of predefined sort of setups for you. A root persistent disk. So when you create a VM, a root persistent disk with the same name, the disk is automatically attached to the instance. So, right. So that shouldn't be too bad. I think it's pretty straightforward. With most like bash, like the man pages, you can just -- help and it'll pull up all the manual pages. So kind of the same thing. Like Miranda said, Google has very good documentation. So that should help. So if you're, for example, running, if you know exactly where you're going to be working and you're always wanting to set things into a specific zone in a specific region, then of course you can change your default values so that it is in the zone and the region you want, so that you don't have to like do the flag every time. It'll just create using the default. So I think, like, for example, let me just run this and kind of show you what that brings up. I think that might be helpful as well. So this is specifically calling the help on cloud compute instances create. So this will show you all of the stuff for create. So this is what it'll show. And because you have to exit out of this, I guess, like kind of like a file, you have to hit Q, and that's how you get back out. So that shouldn't be too bad. Well, it says Control-C. You can stop a command using Control-C if I'm not mistaken, but you can also just hit Q and it'll exit out. Great. So let's take a look at the VMs that we have. So for the first VM, I had connected it to Nginx. So that's why, like I had mentioned, you can pop this out and it'll show you the web page, right? For the second one, we haven't done that, so you aren't able to actually see this from the outside. So that's why the pop-up is not there. And that's also the power of Nginx, if you were wondering. Great. So like we said, everything that you can do from the GUI, we clicked SSH here and it just took us in. You can also do the same from the command line if that's what you're comfortable with. So Gcloud Compute, again, SSH, and we're going to go into the GCE Lab 2. So this part really depends on what you want to do. So for example, before, if you had set a specific zone, then it really depends on what you want to do. So you can specify the zone or you don't have to, I believe. So we are going to go into here and we're going to SSH into GCE Lab 2. Great. So you're just going to say yes. You're going to generate, go for it. And you don't want to passphrase right now, just to keep things simple. So you're going to hit enter again. We're going to leave it, and we are going to leave it empty again. Awesome. Yep, so you can see Debian Linux. Whoops. Great, so that's what we just did. We went through all that fun stuff. Yeah, so as we mentioned, there's two ways. So, I mean, I guess now that I've mentioned there's two ways, you can do both. So you can do it either through the GUI, which is so the Cloud Console is the GUI that we were looking at, and the command line is the Cloud Shell. So we can do both of those, and that's right. So that's it. It's kind of your first introduction into how to set up a VM. And now that we have, now that we know how to set up VMs, we can also, after this, Shardul is going to look into load balancers. And so that'll be a really fun thing to sort of add on to our knowledge today. But this is a really great place to start. And yeah, so see, it won't take really that long. It's 20 minutes. So if everyone is okay, I will end this lab. So that's going to kill the session that we had. And then all of this stuff we are going to lose. So make sure you're happy with everything. Make sure you understand what you're doing before you go ahead and end your lab. Yeah, anything that I should address or make clear?
No, I think we're good.
Awesome.
I don't see any questions in the chat as well, so.
Yeah,
Okay.
we're good to go. Thanks, Kathy.
Awesome. Thank you. Okay, let's go ahead and end this lab. And great, we're happy. We like Google Cloud. All right. So once we've done that, we have created a VM. Actually, we've created 2 VMs. My mistake. So let's go through this. Yeah. So just to touch back on Nginx. So it is an open source web server. So you can, as it says, reverse proxying, caching, and load balancing. So the load balancing is what we're really going to cover today. So provides HTTP capabilities. So that means that requests can go in and it'll be able to handle that, or at least receive it, sorry. And the reason Nginx is used is Nginx was designed for like maximum performance and stability. So because of that, it actually is very quick for users. So any requests that go in come back very quickly, and it is very scalable. So explains why sort of Google likes using it. So we're going to move forward. I think I went through this. My mistake. I think I missed the slide, but yeah, so this is exactly kind of what we covered. If you want to take a look at the slide again, I know I talk a little fast, so this is a nice little summary in case that went over anybody's heads. Okay, great. So this is the next lab. So now we're going to actually take a look at our computing resources. We're going to connect to computing resources hosted on the Google Cloud platform, and then we're going to take a look more at the Qcloud commands. Whoops. So we are done creating a virtual machine. So getting started with Cloud Shell and Qcloud. So since you've already created a VM at this point, you kind of have an idea of what everything does, right? So again, this is going through the exact same stuff. So we are going to start the lab, do all that login again. So let's do that. I think I saw someone mention that that my screen looks a bit different. It's because I'm using a separate email. So just double check with Shardul how to go ahead and do that, because my screen might look a little different. So I'm just going to go ahead and launch with a credit. But essentially, you're doing the same thing. Okay, so I'm going to close this stuff so that I don't get confused. Yeah. Okay, so we're going to log in, do all that fun stuff again. Oh my goodness. Okay. Okay, so again, confirm. So while that's just setting up, oh, that was quick. Okay, so I just want to highlight. So this lab is really just sort of exploring the sort of command line tools that we'll be using and might be useful for you. For example, at the bottom, if I'm not mistaken, in this lab, yes, you can actually install like an interactive mode. So it'll have like auto completes and stuff like that. So it's really nice. So this is kind of what we're trying to get at. Great. So we're going to do this once again. Oh, shoot. We're going to do this once again. And activate the Cloud Shell. Great. Great. Okay, so that's gonna, okay, perfect. So we're going to do the same gcloud auth list, authorize, great, great, great. So we're good to go. So if you ever want to just check what your, for example, your project ID, for example, config list project. So a lot of the sort of this, like the, okay, never mind. We're going to move forward. So we're going to configure the environment. So first and foremost, so it just goes through the regions and zones again, because it's a very important concept. So this is I want to highlight this part. So virtual machine instances and persistent disks live in a zone. If you want to attach a persistent disk to a virtual machine instance, both resources must be in the same zone. So this is incredibly important. So if you have two virtual machines that you want to access the same disk, then they all have to be in, for example, US West 1A. So just keep that in mind if you're trying to maybe access things from different places and something doesn't work. That may be why. So let's take a look at what our default region and zone are. So as we said, we can actually configure these and set values, but right now we just want to see what the default is. So cloud config get value. So we're going to get compute and then zone. So, oh, it's unset. Awesome. So it's unset right now. Great. So this is probably unset as well. Yes, so it is unset. And Google, the Quicklabs even tells you that, whoops, they are unset. But if you did have a default, then that's how you would check it. So if you set a default and you want to check that you set the correct one, then you would use this as well. Great. So let's see. So as Miranda mentioned, the project ID, you can find that right here. Oh, that is not good. Oh my God. Okay, so this is what happened the first time. Shoot. Do either of you guys know how to? Oh shoot. Oh my goodness.
Sorry, what happened, Kathy?
The shell disconnected.
Oh, can you just reload?
Last time I reloaded, it kicked me out.
Oh, are you able to restart the lab real quick? That's another option if you can't get it.
That's true. Shoot. Sorry about that. Let me just try logging in again. It might have. Okay. I think we're back in. Great. So I'm just going to go ahead and do the auth again. Oh, it's actually still great. Recovered. Wonderful. So we can actually continue on where we left off. Okay, so environmental variables. If you're unfamiliar with environmental variables, usually when you sometimes when you like deploy, sometimes have like deployment scripts or, scripts that contain APIs or executables, they kind of need to know what they're working with. So if a script wants to use the project ID to reference your project, then you can set the environmental variable of your project ID to be your project ID. And so that way, when you have to make a call that references your project, then it's all there right in this in the environmental variables. So it just makes writing your scripts easier. So we're going to do that. Okay, so we're going to copy this. So we're going to say project ID equals to, and then we're going to replace this with our project ID. So I'm going to go ahead and do that, and you will find your project ID. Oops, I forgot. And you're going to find your project ID right here. So we're going to copy that. Great. So that's set. Same here. We're going to set the zone to be equal to our zone, which I don't remember what it was with the value. Describe. Oh, apologies. I missed this. Okay, so let's go ahead and get that going. Whoops. And then we're going to copy that into here. Oh my goodness. Okay, so that's going to say it's just going to grab some project information. So we're going to tell it which project we want it to look at. It's going to return some stuff that we are going to use. Yeah, so this is the information you kind of want to see. There it is. So your default zone, Central 1A, and then your default region. So we're actually going to use all of this in the upcoming. So, okay, so we see the project ID, and then we're also going to set a environmental variable for the zone. So we're going to export zone. Oh my goodness. Sorry, I missed that first step, and now I'm just a little bit just fumbling a little. Okay, so this zone, like I said, we're going to find it up here when we described it. So the zone here, US Central 1A. Awesome. So we're going to replace that. Great. Awesome. So now that you've set these, you want to actually check this. So echo is just going to echo it back into it's going to print it out. The $ is going to expand this particular variable. So $zone should expand out to the zone that we gave it. So let's go ahead and try echoing those two things and check that we set them correctly. Yeah. So echo project ID, that is indeed our project ID. And this is indeed the zone that we saw earlier. Here. Great. Okay, so now that we've set that zone, we immediately follow with this command here, and we're actually going to use that variable that we set. So you can see why this makes it easier. You don't have to type out US Central 1 for zone. So like earlier, it's going to create an instance of a VM called Qwiklabs. The machine type is going to be the same one that we've been using, and the zone is going to be this zone that we set up here. I think that's pretty clear, hopefully. If not, please let me know. But let's go ahead and run that and create a new VM using the environmental variable that we set up. So again, it's going to take a minute, so don't be surprised if it's just kind of sitting there. Okay, and then you will be expecting this output. So this output is just showing you that your VM is indeed running. So awesome, which means my VM is running. So yeah, this kind of explains, this breaks down the command, kind of exactly sort of how I explained it. I think that make it very readable to the person. So it's quite self-explanatory, but again, the documentation will help you with that. So far, if everyone is about the same place that I am, we can go ahead and check that our virtual machine was created. Awesome. So is anyone having issues with this check mark? Sometimes it's a little delayed because I guess it just takes a little while for these two things to communicate. But if you do end up having troubles, I think one of the later labs has kept giving me an X. So I just waited a minute or so and tried again, and it worked. So don't get too frustrated, especially if you're setting up multiple virtual machines and this check doesn't go through. It gets kind of frustrating. And in fact, I think that's how I got locked out, possibly. So yeah, so this we actually saw earlier. So I'm going to show it one more time. It's just going to pull up just like the bash man pages. Awesome. So again, Q to exit or Control C, and that's going to kill the command. Okay. So far that's pretty easy, I think. These two commands are a little bit different. You can kind of access the way that these are set up. You can access help pages in more than one way, and also they pop out kind of differently. So if you do a -H, it's going to show you kind of like, oops, there we go. Yeah, so it's going to just pull it up in kind of the way that cat does. It just prints it out to your terminal. So this is kind of like the short, kind of like the shortest version of the help. But if you want to see the full help pages, then you usually just have to add the -- help. So I bet if I hope, yes. So that's going to show up that same. So this is opening the actual file itself, which is why we have to press Q to get out. So that's pretty simple. Like it says, these two commands are equivalent. If you have some bash knowledge, then you can kind of understand, under Gcloud, there's help, and then under help, you can check config, or you can say under Gcloud, there's config, and then there's a help flag. So there's more than one way to sort of get to the same place. Like it says, both return long, very detailed help. Yeah, so if you have some experience with Vim or I can't remember the other one, then you'll know kind of some of the shortcuts, not shortcuts, but some of the keys to get around. So enter to scroll through, and then, to exit, we'll type Q. Great. So we can go ahead and run these. It's really just going to just spit out some stuff, and it just wants to show you the things that you can see, and eventually we want to be able to see all the components that it has available to us. So let's just run each of these commands and just see what each of them do. So config list is going to tell you, the configurations of your environment. So you can kind of see, let me see. Yeah, so there you go. Your project ID is just some stuff in there. So let's see. So the -- all usually is just like the longer version of whatever you were doing without the -- all flag. So if we do that, it's going to show up everything, and even all of the unsets. I believe the difference is that the first one shows only the set ones, and the second one shows all of them, including unset environmental variables. So that does that. So this is where the fun part starts. So we have different components that we can use, and we can install them very easily because we are using the Gcloud SDK. So if you take a look here, we have some that are installed. I'm going to pull this up. We have some that are installed and some that are not installed, even one that's deprecated. So, so you can see kind of like cloud, big table, BigQuery. I assume it's for big data, since it is meant to sort of scale up data, and you have to be able to analyze or use it or do whatever you need to. So there's a lot of fun stuff in here, but we'll take a look. I mean, you can kind of take a look. You can kind of take a look at these things on your own time with all those, with the unlimited access that you have. So now that we can see all the components, let's actually install a new component. And so, like I mentioned, we're going to install Interactive, which can autofill for you. It can show you what kind of options there are for each command. So it's very useful. Kind of feels a little bit more like an IDE that we're used to. So we are going to go ahead and do that. So sudo apt get install cloud SDK. So it's basically just going to grab those things for us. Awesome. So we're going to open that, and then we're going to go ahead and grab this and then enable it. Okay, so building, reading, and it should be installed. Great. It should be installed. We will find out as soon as, whoops. Okay, so if it's installed, then once we hit enable, it should enable. Great. Okay, so now I will actually type something to show you how this works. Please don't laugh at my typing skills. So Qcloud, and so it'll show you, for example, what can come after Qcloud. So what kind of commands are there? You can kind of scroll through, and that's done using tab, which is really nice. And then it'll pull up the little synopsis, so you can kind of see. But we are going to just go ahead and compute, since that's what we are concerned with. So I have tabbed all the way down to compute, but you can just continue typing. And it's done really nicely because as soon as you hit space, which is intuitive, it'll go to the next one and it'll prompt you for the next, I guess, like command or parameter or whatever you might be doing. So we're going to say instances. So we can start typing and it'll show us the things that can autofill. So tab through to cycle and then space. So it's really nice. Describe tab, autocomplete. And then we are going to find our VM, which I believe was GCE lab. Actually, I'm not sure. So if you're not sure, this is a good point to you can do it through here, through the command line, like we can get the, like we did the project ID, we can sort of do that through the command line, or we can go through here and then VM instances. So it really just depends on what you're more comfortable with. Some people are command line whizzes. So it's actually GCE Lab 2. And so if I had just looked down, I would have seen that it already knew that. So yeah, the interactive shell is quite nice. So we're just going to tab, space, done. So we're going to hit enter. And did I mean that? Let's say we did. So yeah, sure. That's the one I meant. No, it's not. Let's try. No. I wonder why, but there it is. So this is describing everything. Great. So I really just wanted to, I don't really care if this works or not right now. I just want to show you what the interactive component can help you do. So just as a quick side note, F2 toggles it on and off, which is, for example, the Qcloud. So that does that, but if I F2, then that's the help. So that should be that. Great. So we are going to, so we've actually done this in the last lab. So this part should be quite straightforward. So we're just going to connect to the VM with SSH. And again, the zone is defined. So we just have to use the $sign to, for it to just expand the variable. So we're just going to paste, whoops. Whoops. Command not found. Oh, sorry. There's a shoot. Sorry about that. It thought my first thought the command started with $sign. Okay, so yes, I do want to continue. So it's going to generate the keys. I don't want a passphrase. Same, and it's going to just be empty, and you're just going to hit enter through that. Great. So all of this stuff just means that we're connected. Yeah, it always tells you, I guess, the license and whatnot. So I guess that's how you can tell. But this is all that output stuff that we just went through. This is just for the sake of demonstration. So now that we know how to do that, just exit out of here. So we've sort of disconnected from our VM. These are all very basic commands. So if you have ever worked in the command prompt, even in Windows or Linux, you should be very familiar with this. So cd, so $home is always going to take us back to our root. So that's going to expand the this home variable. So it's changed us back to the home directory. And vi, so Vim text editor, it all works in here. So if we just do this, we're going to say in this directory, look for .bashrc. So Vim is just going to open that. You'll be able to edit things in here. It's just a text editor, but we are not going to touch anything, and we can :Q to get out. Yes, that's right. Oh, press escape, then :WQ, and WQ actually, I believe with save quit. So :Q does not save, I believe, and then :WQ does save on quit. So that's pretty much it for that. I think we're just on to, that's it. I hope that was easy and not too quick, but I think this is a great way to sort of get your hands dirty and like, how do you create a VM? How do you use that VM? How do you connect to it? How do you disconnect? And just general things that you can do with the Qcloud SDK. So 3 basic ways to interact with Google Cloud services and resources. So I don't know if there might be answers in the chat or something, if someone might want to jump in. I realize there's a bit of a lag, so if not, I can go ahead and yeah, so 3 basic ways to interact. So obviously we did the Cloud Console, which was the GUI that we're looking at, the command line interface, and lastly, so cloud services and resources, client libraries. Should be correct. Awesome. I hope everyone got that correct. I believe that's it for these 2 labs. I think I've talked enough at this point, and you're probably sick of hearing me. So we are going to go on break, and we will be back at, whoops. Oh, okay. We will be back 50, okay. Sorry about that. Great. Well, so we will be back in about 15 minutes at around 4:10. So I'm going to, 4:20, excuse me. So I'm going to leave this up. So if everyone wants to go, stretch your legs, get some water, and, just take a little bit of a breather, we will be back here at 4:20. If you have any issues so far and you might want some help, you've had some technical difficulties or just have some questions, we'll be around monitoring both chats, especially the Discord. So if Miranda and Shardul, if you have anything else to say, if not, I'm going to let them go.
No, I think we're good for now. It's going really well. A good job, by the way, Kathy.
Thanks, you too.
I think, yeah, we're cool to come back at 4:20.
Great. I will leave this up then. Enjoy your break, everybody. You deserve it.
All right. Welcome back, guys. Hopefully that break re-energized you and get back into it. I think Kathy, you might be still unmuted, so I can hear you typing. So if you just want to mute, I think we're good. Okay. So we are going to go into welcome back, guys. The next two labs, which are going to be a bit advanced in talking about welcome back, guys. Kubernetes, load balancers, and containers. And these things come into play when we're talking about release scale and technology companies that operate with hundreds of developers and deploy their applications to thousands, if not millions of users. And so we'll see how we can simplify development and deployment at scale using Google Cloud. So first off, we're going to start off. Let me just full screen. Sorry, 1 second. Let's try to full screen. Okay. First off, we're going to start looking at a common problem that many companies face in their production and deployment environment. And this is when developers try to create new applications or new features, and they change certain libraries or server settings. This often causes problems because you have on your development environment some other version of servers running or libraries running, and you might not have the same versions running up on your production and testing environment. And usually this involves a lot of back and forth between the operations team, and it wastes a lot of developers' time into kind of like doing that back and forth and making sure the production environment is ready to go. And to kind of deal with these problems, what we do is use obviously virtual machines, but they come with a lot of overhead and problems, especially when you're talking about big scale. So hundreds of developers trying to deploy things to production every day. And so we introduced something called containers. Now containers are basically, you can think of them as abstraction away from your app layer, and they kind of bundle your code and libraries together. And the name, as it might suggest, you can think of it as a shipping container, and how they're kind of like standard, kind of these rectangle boxes. Containers are essentially the same thing. You could think of them as like these standard kind of packages that you download and run your application without worrying about any dependencies or setup. It automatically handles everything for you. And when we compare it with VMs, VMs, as Kathy previously showcased, require you to specify your OS because that VM is actually simulating that operating system. So it has all the services that a normal operating system would have. But in contrast, when we look at containers, they just package whatever your application needs. So these are binaries, dependencies, and libraries. So it doesn't actually require you to simulate an entire OS, and you can all just depend on the container runtime to handle all the operating system calls and everything that comes with the OS for you. And so as you can imagine, this brings a lot of benefits. Some of those benefits are kind of the same as virtual machine that provides a consistent runtime environment, kind of an isolated environment to run your application called sandboxing. It also kind of additional benefits. It brings down this the size of your package or container really to a really small amount when compared to virtual machine, because you're not, again, simulating the entire OS. And so this, again, brings low overhead and results in faster startup times, and you don't have to worry about waiting. For instance, if you were to run a virtual machine, you'd have to wait a minute or two to get them up and running, whereas containers, since again they don't require an entire OS, they could be started within 30 seconds. And so we're not going to go into too much depth into exactly how to create a container, but a good thing is Quicklabs actually offers a lab that kind of runs you through that. And the link for that is on the slides, and you can actually go to the slides. You can find the link to the slides in the YouTube description as well if you want to check this lab out at a later point. But with that said, let's look at another problem that comes with scale. Developers, as I mentioned before, need to deploy updates to their application multiple times a day with ideally zero downtime. So this means like when you're, for example, changing versions of servers or a library, you don't want users to kind of face downtime and say that the server is going to be down for a couple of hours, because sometimes you're dealing with really critical services. And so users obviously expect the application and services to be running 24/7. Imagine if Google Slides were to go down right before this presentation, we wouldn't be able to kind of like show and present this to you. And so Google and other tech companies, as well as a lot of enterprise companies, require high availability. So having their applications be running for 24/7 all time of the year. So how do we kind of deal with this problem? Well, Google, in its initial stages of kind of expanding their services, created Kubernetes, which is now an open source technology, and it helps you develop and deploy applications at scale. So you can handle like millions of users using Kubernetes. So what is Kubernetes? It is a container orchestration platform. So it works with containers right out of the box. As we saw before, containers are these packages. So Kubernetes doesn't actually require you to use a specific runtime, but the most popular one is Docker, and it supports Docker right out of the box. And so this container orchestration platform helps you kind of deal with the problems that I mentioned before of like deploying applications multiple times a day, kind of managing them and scaling them to a lot of instances. And it does this all automatically. So you don't need to have necessarily like a 100-man team to kind of manage like real scale, like millions of users. A lot of startups actually use Kubernetes to get their services up and running and kind of deal with explosive growth. Some of the main tech companies that still and continue to use Kubernetes are obviously Google, but then also Shopify, Slack, Robinhood, Lyft, and many more. So let's quickly look at some of the Kubernetes basics, because this will help us kind of understand when we're going through the lab, kind of different terminology and how Kubernetes works in general. So first off, you have your Kubernetes cluster, and this encompasses the entire Kubernetes platform, and it consists of different worker nodes. So these are just virtual machines or physical machines that run the kubelet process, kubelet and container process. And you have a centralized control plane that allows you to manage and interact with the Kubernetes cluster from outside. So if you're deploying applications, if you're scaling things, you can use control plane to get them to get applications up and running and kind of manage them and monitor your status. So if we kind of dive deep and look at single nodes, we can see further kind of abstraction within each node. Within each node, you have what's called a pod, and pod are the smallest unit of deployment within Kubernetes. And these actually are the things that contain your containerized applications. And also they come with volumes. So you could configure, some applications require you to persist data onto the machine. So you can create a volume using Kubernetes. And usually within each pod, you only have one containerized application running. Here you can see there's multiple volumes and multiple containers kind of displayed. But this is generally an advanced use case. And most likely you're always going to have one containerized application and one pod within each, or one containerized application within each pod. So let's look at how we can actually deploy this to Kubernetes and create web services using deployments and services. So the basic way of like creating applications that run on your cluster are called deployment, and they're responsible for managing, creating, updating instances of your application. So here you can see in this image, this is considered a deployment. So you might have not just one instance of your application, but multiple. And this can be configured in the deployment that you're going to create. And later on, we're going to look at how we actually create the deployment to make this possible. To kind of expose your application to an external internet, so like public internet, you need another step. That is to create a service. Service enables you to kind of expose your application to public traffic, and it allows you to kind of load balance traffic among the instances that you declare in your deployment. So here you can see that this deployment creates 3 pods, and this service kind of distributes the load automatically to these different pods. And we're going to talk about load balancing in the next lab, but Kubernetes handles load balancing for us. So it's really great. But quickly, just to put everything together, the way we deploy and scale our applications are to kind of take this approach of making sure that all of our applications are containerized. And so that just means building a Docker container when we actually develop the application, so they can be easily shipped and deployed at any location. The next step is to store them at one place, and the common way to kind of store and version your Docker images is to use a container registry. Google does provide you with a container registry that you can configure for your own organization or for your own personal projects, but you can also use their public container registry to pull images from. And so once you have that kind of Docker image created and shipped to container registry, the last step is to deploy it. And the way that works is using a Kubernetes engine. So obviously, we're going to look at how to deploy a Kubernetes engine, but after you've done that, you can simply type a command to pull that Docker image from that container registry and have it up and running within a matter of seconds using Kubernetes. So it's really exciting how everything works together, and it really achieves millions of users. You can scale your application to millions of users. So if by any chance you're thinking of starting a startup, this is a great choice. It does come with a bit of cost if you don't have it configured properly, but we're going to quickly jump into the lab and see how we can configure a simple application or a simple Kubernetes cluster and then deploy an application using Kubernetes. So I'm going to share, I'm going to split my screen in half. Sorry. Close this up. Oops. Okay, hopefully you can see my screen and this is readable. Just gonna make sure. And we're gonna go into the Kubernetes Engine Quick Start Lab. I'll just give people a couple of seconds to get in here to this lab. Okay. All right. Awesome. So Google actually, or Qwiklabs actually gives you a kind of brief overview of how Kubernetes engine works and how Google actually uses that service to deploy their own services. So you can read up on that, but we're just going to get started with our first task because we already kind of went over the basics, and we're just going to start it with the lab itself. So I'll go ahead and start the lab. Use my subscription, and this is going to get us an account, as you guys are familiar with it already. I'm going to open Google Console in a new Incognito website. Okay. And I'm just going to copy the username and password from here. Accept. Sure. Just gonna wait, give that a couple seconds. Okay, there we go. We don't have to worry about the setup and requirements, by the way. It's gonna automatically be done for us when we jump into the first task. But quickly, we'll have to go through this and then open up our Cloud Shell. Continue. Okay, so I'm gonna pop this open in a new tab. Just wait for that to boot up. All right, awesome. I'm gonna try to get this zoomed in so you can see better. Okay, so let's get started with the first task. So again, we're just gonna quickly set up our compute zone as US Central A. So this is where our Kubernetes cluster is gonna live. And obviously it's asking me to authorize, so I'm just gonna go ahead and do that. Right, so compute zone is set up. Now we can go ahead and create our Kubernetes cluster. Awesome, so let's go to task 2. As we saw before, Kubernetes cluster relies on different worker nodes, and these worker nodes, as you may recall, depend on either or run on either virtual machine or a physical machine. So what we're going to do now is to create a cluster of 3 virtual machines, and you don't have to kind of like, as you saw before, write that compute instance create command like multiple times. Google already has like a cluster command for us. And so make sure when you copy paste, just name your cluster here and make sure it's proper name. And this is going to take a bit of time because, as I mentioned, this is going to set up 3 virtual machines for us. If you need to verify kind of it being configured, you can go back and go to compute and then go to VM instances. And you can see here, it's going to show up our 3 virtual machines after it's done creating them. I think it's still being created, so it'll take some time. But in the meantime, if anyone has any questions, I'll kind of quickly check the chat to answer them. Okay. And if you actually end up finishing before me, you can go ahead and create or like check my progress to make sure you've finished this step. All right, I don't see any messages, so hopefully everyone's also stuck on this loading screen. So we'll give it a couple minutes until it's done. And check my Google Cloud platform, see if that's updating. Awesome, so I see here, it has created 3 instances, but let's see if I am, okay, so this is still waiting on confirmation from, I guess, Google Cloud to see if they are created. So I think it's just going to take a minute or 2 more. And so again, this creates 3 instances of virtual machines, but as you can see here, it says master is healthy. So one of those nodes is going to act as your master node, and the master node essentially takes care of kind of managing communication between different nodes and also the control plane. So acting as a medium to kind of drop between the node statuses and also the API that you'll be using to access the cluster. So we're just going to give that a couple of more minutes. See that it's created. Awesome. So I think it's done. It might take you also a couple couple of more minutes, but when you're done, you can go ahead and check my progress to make sure that Quicklabs recognizes, sorry, that you've completed that stuff, and make sure that it also shows up here so that you're tracking your progress, and you're good to go ahead to task 3. So hopefully everyone's good to go. I'm gonna quickly, task three is pretty simple. It's just running one command that kind of authenticates you with the cluster. So before I run that, I'll just make sure that everyone's kind of caught up. Do you guys see anything on the Discord, by the way, Kathy or Miranda?
It looks, yeah, everything looks okay.
Okay, thanks. All right, so I think we can move on to authenticating ourselves with the cluster. So this is important because Kubernetes automatically comes with security built in, and it doesn't allow you to just interact with the cluster by just being on that machine. So we need to first get credentials to the cluster, and to do that, we want specify the same cluster name that you gave up here. So make a note of that. You'll probably, I think, use it later as well when you're deleting the cluster and deploying applications to it. So I'm just going to go ahead and run that. All right, so that's what that has done is it's created a kube config file, and that this basically defines authentication for you. And it's a customizable, and you can, as you saw in the first lab, you could set roles in Google Cloud itself. Similarly, it kind of the Kubernetes cluster uses the same approach, and it provides you with roles and authentication permissions for each cluster and action that you can perform on the cluster. But for this lab, we just need root access. So we have gotten that by running this command. So we're just going to go to task 4. And task 4 is where the fun stuff happens. So now we have our cluster created. We're going to go ahead and deploy a simple web application. And to create that, we use, as we saw before, a deployment. And to create the deployment, usually you have to write a YAML file defining the configuration that that application will run. But deployment are also automatically generated if you just specify the image name. And Kubernetes will create a default deployment for you. So we're going to go ahead and create this deployment. And to do that, you just run this command. And you should see that deployment has been created. Now, to verify that our deployment has been created, and to kind of look at what that deployment looks like, we can run, and you don't need to run this on your end, but to find out what that file actually looks like, we can say get deploy, and this is the shorthand for deployment. Hello server, output YAML. And so this kind of throws out that configuration that I was talking about. And so this is something that you would write if you were to create something for production at a company, for example, because you'd want to specify, for example, replica sets. Let me see if I can find that here. Replica is here, so that defines how many instances of that pod or containerized application that you will be running on the cluster. And then also you have other stuff like rolling updates that allow you to ensure that there's no downtime. So it says you can have your services be maximum unavailable for 25%, and other configurations like that. So that basically has created our application for us. And if we go ahead and check our progress, it should we should be good to go. So now that we know our application is running on the cluster, let me just clear this up so you guys can see what I type next. Okay, awesome. So as we talked about before, Google or Kubernetes, when you create a deployment, it just runs it in the private network. What we need to do now to access it using our browser is to create a service. And service, as I mentioned, does come with a load balancer. In this case, it's not really, it doesn't really make sense because we only have one replica, as you saw before. But we're still to demonstrate the feature, type out the load balancer flag. And so if we go ahead and create this, service has been created. So now our application should be exposed to the public internet. So to test it out, so the next step involves you to get the IP address that we can call to see if this cluster or application is running. To do that, we type in get service. So this lists all the services that are running on the Kubernetes cluster. Our first application that you see here is the one that we created. And so hello server, and the external IP is still pending. So it might take a while to get that service up and running. So we're just gonna try it again, and there we go. Now the external IP has been created. That means our service is up and running, and the Kubernetes cluster is ready to expose this application to the public internet. So if I go ahead and, create a tab and visit this website on port 80, which is the standard TCP port, it should return me with the HTML that we created using our application. Actually, make sure that you have HTTP specified. Should be should return an HTML file like so. If it takes a little while, just make sure that you have the right IP address copied. I think the port that we configured, or the default service configures, is 8080. And so you should be able to see on port 8080 the website being returned. And if you are seeing that, then that means you're good. If anyone has any problems, just type it in the chat. Again, you're just creating a deployment and then exposing it to the public internet by using a service. And that was this command, expose. All right, awesome. So I'm just going to close that out and check my progress to see if Quicklabs recognizes. Okay, awesome. So I am done with this third step as well. The last step is just deleting the cluster, because as I mentioned, this is using 3 virtual machines. So in real world, actually, it would take, it would be pretty costly to have this up and running and all the time. So sometimes for personal projects, it doesn't make sense to use Kubernetes, but it's a great way to kind of get familiar with industry use cases. And you might be actually using Kubernetes platform when you go to do your internships or actual full-time work. And so lastly, we'll just run our delete command. Just going to specify the cluster name, cluster, and this is going to go ahead and say yes. And this is going to go ahead and delete our cluster for us. And this might also take quite a bit of time, because it basically goes to the different virtual machines and tries to bring them down. So it might take a while to get that deleted, but you can leave that up and running. And if you want, you can move ahead to the next lab. I'm just going to wait a bit and see if it's done within a minute or two. If not, we can go ahead and move to our next topic. So I'm quickly check Discord if anyone has any questions. Oops. All right, awesome. I think we're looking good. Hopefully everyone's getting through this. Let's go ahead and check our progress to make sure, to see if it's, I think we gotta wait till all of those VM instances are kind of brought down. In the meantime, I am going to switch back to the slides and quickly talk about load balancing, and then wait for that to complete. Let's quickly present this. Right. Awesome. All right, so we looked at Kubernetes and how to create a cluster on the cloud. Again, as I mentioned, this might be costly for purposes that you might be, your projects might be working with. And so like, it's not ideal to always create applications to and deploy them to Kubernetes. Sometimes you might be using, even as a startup, you might be using just virtual machines to deploy and run your applications on. But sometimes you might see explosive growth, or just even in internships, you might see this use case might come up. For example, if you're working at Shopify or like one of those big companies where they do a lot of online work, and you expect users to coming in at, for example, if you're hosting a sale on a certain item, you might see an influx of users just randomly kind of hit your services, and you will notice that your VM take a bit of hit and kind of almost go down and sometimes crash. And to introduce redundancy into your services and to make sure they are up and running always, you might want to use a load balancer to kind of distribute the load between your services. And so there's two really main types of load balancers that are used in the industry, one of which is network load balancer, and the other one is HTTP load balancer. And these work on different kind of layers of the OSI model. OSI model, if you don't know, is basically a model describing kind of the tech stack, or kind of the interconnections between the different layers. So at the bottom, you have your physical layer, then data link, network, transport, session, presentation, and then application. So application is what you usually see. Everything else is kind of abstracted away from you, and you don't necessarily have to interact with that unless you're a developer. But if we're talking about the application load balancer, we usually refer this to as L7 load balancer, and that operates at the things that you see. So application layer is where the application load balancer operates at. And it's essential to note the differences here, because being at the top, application load balancers can decide based on variables from HTTP request and network, so all the way from 7 to 3. It can operate on all those variables and decide where to distribute traffic. And this is called being context aware. Whereas if we look at network load balancers, they just rely on things like IP address, destination ports, and protocol. And you might be a bit confused as to why network load balancers operate at L4 instead of L3, as the name might suggest. This is because network load balancers can also look at protocol. So TCP, UDP, HTTP, things like that. You don't need to necessarily know what those are, but just know that network load balancer kind of can operate either at L3 or L4. And since it doesn't have all the variables kind of that application load balancer might have, it can only decide where to direct traffic based on these parameters. Sorry. So let's go ahead and quickly jump into creating a network load balancer. I'm going to go ahead and quickly check our progress for deleting cluster. Hopefully that's done. Awesome. So that has finished as well. So I don't know if I have the right. I'm just going to close this out since we don't need this anymore, and get on with the next lab. Make sure you end the lab because sometimes Quicklabs doesn't kind of register your progress. So go ahead and end the lab, go back, and then go to our last lab. All right, so go ahead and start the lab. Your subscription. All right. So it's going to create another account for us. I'm going to go ahead and create an Incognito website window. Then just fill out the student email as well as the password. All right, go through the standard setup. By the way, did everyone complete the last lab? Make sure if you do have that still open to go back and check your progress and that lab. I'll just quickly check in the Discord if there's. Yes, so I do see a message here. Can you create a local instance of Kubernetes on-premise server? Yes, you can. I actually did that in my internship. It does require a bit of setup, as Kathy mentioned, because you have to do some of the heavy lifting like by yourself, since it's not managed by GCP. So it does require a bit of work, but it is totally possible. But usually companies rather just, since Kubernetes is more suited towards cloud, they only kind of migrate to Kubernetes if they're thinking about migrating to cloud. But it's totally possible to do it on premise. All right, so we have our Google Cloud platform set up for us. I'm going to go ahead and create a Cloud Shell. And Quicklabs does provide you with a lot of resources. So if you're still not clear on kind of how, I know I quickly just kind of briefly explain what load balancers are, but they're a lot more complicated, and they can be configured to run in a lot of different ways. And you can specify your own strategies of how to distribute traffic. But if you'd like to kind of dive deep, you can check these links out, and Google's documentation kind of walks you through a detailed explanation of what those load balancers are and how they work on the Google Cloud platform. But for this lab, everyone must be tired, so we're just gonna kind of through this. So we're gonna start off by, again, at task 1, and let me just make sure to zoom this in. Right, awesome. Okay, zoom out a bit here. Okay. All right, so first thing we're going to do, obviously, is set our region to specify where our load balancer is going to run. So by default, we're going with central, and run those 2 commands so that you have that configured. And once you have that, we'll go ahead and create our actual load balancers. Now, as you saw in the slide, let me quickly go back. Slide here. You see that there's 3 instances created in front of or like behind a load balancer. Obviously, load balancing doesn't make sense if you just have 1 instance. So what we're going to do in this step is to create those 3 instances. And there's a much easier way to kind of create multiple instances if they're going to be the same type of instances or VMs. But since we want these instances to be kind of distinguishable, we are going to create them individually, because as you may note that each of them return a slightly different HTML. And this is so that we just can check whether our load balancer is working. So let's go ahead and run those 3 commands and make sure you run them. You're not just running the first one. They are a bit different. All of them, I believe, are different numbers. So www1, ww2, and 3. So just make sure, yep, run that. And again, what this is doing is it's setting up a Debian VM with this tag, network load balancer tag. So this is nothing but just a name to kind of identify this virtual machine. And as you can notice, it also uses the same tag as here. So you can group tags together and two virtual machines can have the same tags. And to quickly also explain what's happening here is it's specifying a startup script that updates your package manager and then updates the latest version of the Apache server. And it's going to create a default HTML file in our root directory that the server is going to serve. So I believe I'm just missing the last command. And I'm going to let that finish. Also, you might notice that the zone is being set here as US Central 1. And this is essential because for network load balancers, they can only work within a zone. So they can't be globally distributed. You'll see later that HTTP load balancers could be globally distributed using Google's Google Cloud. But for network load balancers, they only work within a zone. Awesome. So we have all of our 3 instances created. What we're going to do next is to create our firewall rules that will allow us to kind of hit those virtual machines from external traffic. So by default, it doesn't allow TCP traffic. It only allows SSH traffic to your virtual machines. So it does give you, when you create your virtual machines, you might have noticed it gave you an external IP, but that can be only reached by SSH and not TCP. So what we're doing here is telling the firewall to just allow us to access those virtual machines using this TCP port. Right. So once you have that, what we're going to run are the list command to see all the VMs that we created. And awesome. So we see all of them are created in this single zone, and they're all ready to go with their external IPs. Awesome. And if we try to now, just to kind of demonstrate what I was mentioning here, if we now try to curl, which is basically getting the HTML response from one of these machines, we'll see, whoops. I'm just gonna copy paste the single IP address. Oh, I don't know. Okay, I think it's still copying it over. It's not overwriting, but it's just hidden for some reason. But it is working. I can verify that by the response that I received. So I'm seeing ww1 return. If I go ahead and run the command again, but with another IP, I should also see the output that is received, or that the second server returns. And similarly, just to demonstrate that our other machine is also working, I'm just going to copy and the last IP address. So awesome. So we see all of those VMs are up and running, are accessible by the public internet. So we can go ahead and check progress to make sure Quicklab recognizes that we're still on track. And also make sure that it shows up here. Next up, we're going to create our load balancer. So essentially what we're going to do is use a static IP address to route all the incoming traffic to the load balancer, and then distribute that into a target pool. A target pool basically means a collection of virtual machines. And you're going to see that later down in this third step. We're going to create a target pool and add all of our instances. And so load balancers will forward that request to our target pools, and one of the VMs is going to respond directly to the client with that incoming request. So let's go ahead and create our static IP address first. And Google, obviously, if you were to use this if you were to create a static IP address, that there is a lot of kind of work to be done on the networking side of things, but obviously Google Cloud automatically handles all of that for us with just one command. So make sure you're seeing the right response, and that's going to go ahead and create our static IP address. Next up, we're going to create an HTTP health check. So what this does is it makes sure that all of your VMs are healthy and up and running at all times, because you don't want to route a request to a VM that's crashed or not running. And it is essential for load balancers, especially because they distribute your incoming request across all the VM instances. So this kind of just makes sure that our load balancer recognizes what VM instances are up and running. And again, Google Cloud only requires us to run one command to create this and set this up. All right, so the next step is to create a target pool. This is where our instances are going to live. And this is nothing but a collection that is kind of abstractly defined for load balancers. So it's not like a physical machine or like even a virtual machine that's kind of grouping these things together. It's just something configured in the Google Cloud to recognize that this pool represents these three virtual machines. All right, so the next step is to, since we created a target pool entry, now we have to add those instances to that target pool. So we're going to run this command, and as you can see here, it specifies the VM names. And so this will go ahead and add our VMs to the target pool. And just clear this up so we can see. All right. And the last step, as I mentioned before, is to create a forwarding rule. And this forwarding rule is what enables your load balancer. Right now, all we have is a health check, target pool, but we don't have our actual load balancer. And so what this is going to do is going to take the static IP address and create that link of kind of routing those requests to your virtual machines, as you see here. So we're going to run this, copy this command, and just run this. And you're going to see later that HTTP load balancer is going to require a bit of more setup as compared to network load balancer, because network load balancer, as I mentioned before, doesn't require you to be context aware, and it only relies on static IP address, destination port, and protocol. So it's not really something that you have to configure and set up a backend service for. Just a forwarding rule is enough to kind of set that load balancer up. And to also quickly just mention that network load balancers, because they're contextless, they allow you to distribute load much faster, and it doesn't add any overhead. Whereas if you look at HTTP and application load balancer, they do require a bit of overhead because they're running essentially an application that decides where to distribute your traffic. Right. So once you have that forwarding rule created, it is going to take a bit of time to kind of propagate that throughout your virtual machine and Google Cloud. So if you click this right after you run this command, it might work. But since I ran this a couple seconds ago, it has recognized that my load balancer is up and running. And now to quickly verify that our load balancer actually works, we first will get our static IP address that we're gonna hit. And this is our load balancer. So run this command to get the IP address. It should be one of the first things listed here. And we're gonna run this simple bash loop that specifies, or like that will basically hit that IP address until you exit out. So if you run this, make sure you hit Control-C before it throws you out of the Google shell. So I'm just going to quickly demonstrate this and change the IP address to the one I find here. Right, and I'm going to run this and quickly press Control-C and kind of go back and see what's happening here. So as you can see here, we created those 3 VMs with all different HTML files. And you can see that none of these requests, even though they're to the same IP address, return the same thing. And so that means our load balancer is actually working and is distributing that load between all of our VM instances. And it's not just returning and hitting the same VM every time. Awesome. So that kind of wraps it up for our network load balancers. I'm going to go ahead and clear this up. And we're going to go ahead and go to our next step, which is creating an application load balancer. So application load balancer, you can read here, it actually mentions what I talked about before, is that they can be globally distributed, and they allow you to kind of use URL rules among other variables to distribute your incoming request across different regions and even across different zones. And they use something different rather than using the forwarding rules that we saw here. They actually use a backend service. So we're going to see that later on in the later steps. But to get started, we're just going to go ahead and create this, run this first command. And you might notice a bit difference here is that it's creating a template and not really a virtual machine to set up our backend. It's because we can actually create a template to tell Google Cloud, this is what my other virtual machines should also follow. And so if we look at the second command, here is where our VMs are going to be created. And so it passes an argument of template and size. So that basically means that we're creating, using this template, 2 virtual machines in zone US Central. And for this lab, again, we're not demonstrating a global load balancer. We're just going to stick with US Central. So we're gonna, all of our traffic and everything will be routed to that one zone. And so we're gonna give this a bit of time. While you're going through this, it might be helpful to kind of quickly look at the slides to understand. Here's the load balancer kind of diagram and see what's going on here. So you can see it's isolated within one region, and it returns kind of the server response directly to the user. And if you go ahead and look at the HTTP load balancer, it's a bit more complicated, but this might be helpful as we're walking through the lab to understand what's really going on. Awesome. So you can see our 2 virtual machines have been created. And 2 virtual machines that you can see from target size have been created. They are called this LB backend group, and this is going to be useful for later, but we are good to move ahead to our next step. So our next step is kind of similar to what we did before. This is setting up again a firewall rule to allow TCP requests coming in at port 80. And this is not for any external IP addresses. You can see there's a range specified. Sorry, let me just copy this so you can see a bit better. This specifies a specific a range of IP addresses, and this essentially is talking about or allowing Google Cloud Health checking services to make sure your VMs are up and running. And this is not possible in network load balancers. You can't use this global service because obviously network load balancers are restricted to a zone. So Google doesn't allow you to kind of run this global check on your VMs. But for HTTP load balancers is possible. So we're going to set this up. So that's going to take a bit of time. Yeah, so that was pretty quick actually. And next up, we are going to do another similar step that as we did in network load balancer, is to create a static IP address. And this is needed because obviously you're hitting the load balancer first, even though it's a HTTP load balancer. All of your requests does actually go to that one IP address. And so we're going to create that, that IP address. And you can see it's been created. You might notice that I mentioned before, like we were sticking with the one zone. Why are we specifying a global flag here? That's just to allow our firewall rules to kind of hit our VMs. And global allows you to kind of declare IP addresses across different zones. So now that we have our static IP address created, we're still going to create a legacy HTTP health check. And this is going to be used when we create our backend service in the next step, because we have to specify a health check flag so that the load balancer could itself check if your VMs are up and running. So we're going to create that health check. Awesome. So that has created a HTTP health check for us. And now we're good to move on to our next step, which is configuring our load balancer. So load balancers, it's a bit confusing how they name it. Backend services are not what you might think of like as applications in Google Cloud. Backend services specifically in Google Cloud refers to load balancers. And they can also be configured to something else, but they essentially act as an intercept to kind of catch the incoming request. I think that's why they named it backend services. But for our purposes, we are going to focus on load balancers. And here we specify the instance group. As I mentioned, that we saw that those two VMs that we created belong to this instance group. So we specify that here when we're creating the service. We also have to specify the zone because this backend services is only going to act, is only going to live within this zone. And then we're specifying global just to make sure that if in the future we do add more incoming requests, we can make sure that they can scale to other zones as well. Okay, so I think so it's giving me an error. I think that's because I skipped this step is to create the backend service. Sorry about that. And so the step that I went over is adding a backend services. Here you're initializing it. So with the health check, port and protocol. So this is what's gonna be accepted for this backend services. And then we're gonna go ahead and add a backend to our backend service. And this is a bit confusing, but what this is essentially doing is specifying our actual backend that we care about and we're directing traffic to, since we're declaring an instance group to reach when we're running this command. So before, again, to reiterate, we are here creating the backend services and just declaring it. And here we're adding our VMs. Let's go ahead and run that. And that should work now and not give me the same error. Okay, awesome. So that has created a backend service, or like we've hooked up. Just to quickly go back to the slides, we've done this part of the setup. So what's remaining is kind of figuring out this three steps. So that's what we're going to do next. All right, so we are at step 8. In step 8, essentially creates this URL map for you. URL map essentially just maps incoming URL requests. So essentially, when you go to a website that, for example, like here, you see that the URL has like different parameters and routes within it. So URL map allows you to kind of, using that URL, map to different backend services and different backends. So here, we're just going to copy this and add this here. So as I mentioned, you can actually direct traffic to multiple backend services. But since we're only setting it up for one backend service that we created here, we're just going to route all of our URLs to that one backend service. All right, so that's created. I'm just going to go ahead and clear that up to make sure that you can see. Next step is creating the target HTTP proxy, and this allows you to make sure that those URL maps actually work, because right now the URL maps that are defined within Google Cloud are just an object, and they're not like a physical or like a virtual machine that is going to be directing the traffic. They're just like an object that defines the configuration for those rules. And so we need an HTTP proxy, which kind of intercepts the incoming traffic and uses that URL map that we created to decide where your traffic should go. So we're going to run that, make sure you have that the name correct. And that has created the HTTP proxy for us. The last step remaining is to create a forwarding rules. And this is this step. This is also needed here because we have our target proxy and everything set up, and our static IP set up, but we haven't connected those two. So services or like requests coming in are not yet going to the HTTP proxy. So we're just going to run this command that takes in that static IP address and routes it to our proxy server. And just run that command. This is going to take a bit of time to set up, because it's essentially now completing this this whole link, and it's setting up the proxy as well as the forwarding rules. Awesome. So it's created. It's showing it's created, but it is going to take a bit of time. So if you go ahead and click this, check my progress, it's not going to work. Because if we go back to our cloud and see our forwarding rules, I think it's forwarding rules. It's not gonna show up here. What we're looking for here is HTTP content rule, and since that's not showing up here, it's not configured yet. But we can see our backend be configured for us if we go to networking services, load balancing, and it should show up that awesome. So it has recognized that our backend service for that load balancing is working. And if I go ahead and click that the backend service setup, we can see that both of our VMs are healthy and the load balancer is up and running. Awesome. So make sure, okay, awesome. So that was pretty quick. The last time I did it took about 5 minutes. So it might take longer for you. But in the meantime, if there are any questions, feel free to leave them in the chat or in the Discord. I'm just going to check that really quick because we're almost done with the lab. And Kathy or Miranda, you can also unmute if I missed questions in Discord.
Okay, hey Shardul. So we had a user ask a question. He said, As per the commands we are running, I assume we can create and activate network as well as application load balancers at the same time and run them simultaneously. Do you know anything about that?
Yeah, that's totally true. If you see here, you can still see my target pool that I created in the first task. It's still up and running, and it's still serving those same instances. So a lot of times, actually, in industry, also you could have multiple load balancers kind of lined up in front of each other. It might not necessarily be ideal to have that because that just adds a lot of overhead. But in certain scenarios, it is possible, especially if you're using like a cache server in front of your application. You might introduce a load balancer there, and then from cache to your actual application server, you might introduce another load balancer there. And it could also obviously depend on the type of load balancer. So you could have a network load balancer in front of your application, and then an HTTP load balancer in front of your cache. So you can, yes, you can have multiple load balancers kind of set up simultaneously.
Okay, thanks, Shardul. I hope that answered your question. If not, just ping in the Discord again. And
yeah, I have the Discord open, so you can ask again if that answer your question. For others, like if you just make sure to check your progress and make sure the step is done while we kind of wait and go ahead and test our load balancers in a couple of minutes. Okay, awesome. I see you're all good. Okay, I think we're gonna go to task 6. This is just the last step to kind of test that our load balancer is actually working. And to do this, we can go ahead and get the IP address from our FICO pack. The IP address is basically the static IP address that we created before. So to get that IP address, I think we can run compute. We can either go on to I think load balancing details and see the IP address listed here. So again, this is going into networking, network services, load balancing, and then clicking on web map HTTP. You also, I think you can run the command of get gcloud command that gets the IP address. Since you already have the name here, you can find this IP address using that command. Just going to copy this and append the HTTP in front of this. And I see the response being returned. And now to make sure that we are receiving responses from both of the VMs, if you just go ahead and quickly just refresh a bunch of times, you should see the host name change each time or every other time that you refresh. And that signifies basically that we are receiving responses from both of those load balancers or both of those VM instances instead of just one machine. And it might not be obvious as to kind of like how that really differentiates between the application load balancer and network load balancer. You can actually run through this kind of steps to realize what the differences are. Basically, the real kind of difference that's happening here are these 3 steps. And in this configuration, it's actually pretty much similar to network load balancers, but in a more advanced use case, you could see this step being broken out and kind of branched out to different backend services that might again branch out to different VM kind of instance groups. So obviously some applications, for examples, might not be serving, or you might have another VM group that's kind of serving a different route. And this is particularly true in kind of big tech companies, because a lot of the times, if you think about how the dev teams are split, you could have a split basically on even the URL that your application or your team owns. And so if you look at something, I think when I was at work, we were using this Azure product. And Azure has a lot of, much like Google Cloud, has a lot of different services. So actually, if I go back to this Google Cloud platform, and if I, for example, click on Cloud DNS, you could have this kind of URL be obviously served by entirely another instance group handled by another team. And if I go back to load balancing, this could be another instance group handled by obviously another dev team. So you could kind of see like it really differentiates. The differences are kind of specified here, and this is not possible to kind of have that branch out for the network load balancers. But application and HTTP load balancers allow you to do this. Awesome. So that should be kind of it for the lab, and you should verify that you have all of those checked out. If not, you can obviously message us in the chat, and you don't have to obviously finish it like right now. I think that is pretty much all I had. So I'm gonna quickly, if there are no questions, I'm gonna hand it back to Miranda to kind of conclude our workshop here. I know it was a long one, but thank you for kind of sticking through it, and hopefully you've kind of made it this far by following along. And Miranda, I think you can take over. I'm just gonna stop sharing my screen.
Sure, sounds good. Thanks, Shardul. Let me just pull up the slides here. I think my computer is telling me it needs a break after all of this Zoom and lots of things going on, but that's okay. Do you see my screen? I think it's loading.
Yeah, we can see it.
Yeah, okay, awesome. So yeah, congratulations. So honestly, good job on completing this. If you have not completed everything yet or still want to go back, that's totally okay. So if you had your access, if you activated it today, you have up to 1 month to complete this whole quest. Although I'm going to talk a bit later about some giveaways, to be entered into that, we do need to have the the quest completed by tomorrow at 6 p.m. But that's okay. So something super cool that Quicklabs has is every course you complete is you get a badge for it. So it looks like these up here. And these badges you can share on your social media, as well as add it as a credential or certification in your LinkedIn profile. So I actually haven't done it yet. I'm going to go through the process of how to make your profile public. So you can share it on LinkedIn, which is what I'm going to do right now. So if you go to your Quicklabs and you go to profile here. Okay, so mine is already public. I believe there's a button here that says make your profile public. If I honestly, I think it's just a simple button, and then your profile shows up like this. If you can't get it to work, just let us know, and we can help you walk through it. So this is my Quicklabs page. So it has like my name, picture, and then this is the badge that we earned from this quest. So it's super cool if we can share that. So let's go to my LinkedIn. Feel free to add me on LinkedIn, by the way. We can keep in touch. So if you scroll down all the way to license and certifications, you click this plus sign to add a new one. And you can enter the name of the certification here. So let's just go back here to get the exact name, Google Cloud Essentials. Okay, Google. Awesome. And then the organization will be Quicklabs. Yeah, and shows up with a picture there. This one doesn't expire, so you can click this box. The month is March, year 21. Okay, Kathy just made a post. Yeah, if there's no button to make your profile public, go to My Learning tab and there should be a button to do so. Okay, thank you, Kathy. I already did it before. I think it's a bit more complicated to undo it and redo it. So, okay, so then when there's no ID for this credential, some credentials have like an ID number, but this one you can copy the link, and this will, when people click on this certification, it can bring you to that profile. So this credential URL, just paste that in there, and that's it.
Sorry, if I can also interject, that link is also what we'll be using to confirm that you created the quest, or sorry, finish the quest when you sign up for the giveaway. So just make sure you can find that. That's all.
Yeah, for sure. Okay. Shardul posted a picture in the Discord. So there's a My Learning tab, and then you view public profile. Okay, thank you for doing that. Yeah, so now this credential is on my LinkedIn, and it's for everyone to see. So hopefully you guys can add this to your profile as well. It really makes your profile stand out that you have like Google Cloud knowledge, especially if you're still in school and looking for an internship. This can definitely set you apart from all of your peers potentially competing for the same job. So that's super exciting. Feel free to make a LinkedIn post as well. You can share your profile or a picture of the badge. Honestly, like making LinkedIn posts is a really great way to get your profile noticed. Like one day I had over 200 views on my profile when I posted I went to a hackathon or something. So just to keep that in mind. Okay, so now I'm gonna go through how to enter our giveaway. Okay, so just actually this slide before. If you're not done, you can complete the remaining labs. And now you have 30 days free access. Once you complete it, you have 60 days free access. So yeah, I wanted to show you all of the labs on Quicklabs. So if you go to the Quicklabs catalog, there are so many different quests that you can complete. It even says here, like from 30-minute individual labs to multi-day courses, like introductory level to expert level. There's so many options. I would suggest like looking through these categories, whatever you're interested in, like infrastructure, machine learning, and you guys have 60 days free access to this. So I would definitely take advantage of it while you can. This stuff is super cool and super relevant in the industry as well. So yeah, let me go to the next slide. Yeah, so complete this form. We have a giveaway. This is just that we are hosting. Like it's only through us, it's not through Google or anything. So if you submit this Google form showing that your profile has that badge, you'll be entered into a giveaway, and there will be 2 winners for this giveaway. You'll each get $10 Amazon gift card and 50 Quicklabs credits. So you might be thinking like, oh, why do I need 50 credits if I have 2 months free access? But what's awesome about these credits is they don't expire. So if you're like too busy with exams and stuff now, and maybe next month as well, these 50 credits will never expire. So they'd be super great to have. So Kathy posted the giveaway link in the form, in the Discord. I think if we posted in the YouTube there as well. Yeah, just to mention again, it has to be submitted before tomorrow at 6 p.m. So you get like around 24 hours just to complete everything. If you don't want to enter the giveaway, you can definitely take more time than that. And we will reach out to the winners tomorrow before midnight. So.
Oh, sorry, just to interject.
Yeah, no problem.
That's before March 31st, 11:59.
Oh, was it? Sorry.
No problem, no problem. So we'll give you guys until tomorrow, 6 p.m. to complete the quest, and then give us some time for logistics, and then we'll reach out to the winners sometime before, maybe even sooner than March 31st. So look out in those emails.
Okay.
Yeah.
Sorry, that was a typo on the slide, and I just kind of went with it. I should.
No worry.
Yeah, so we'll let you know by March 31st. So like we won't ghost you or anything if you do end up winning. So okay, thank you, Kathy. Yeah, so this concludes the Cloud Study Jam for Google Cloud Essentials. Thank you so much for participating in this event and sticking with it all the way to the end. I really hope that you guys have learned some, even if you are brand new to cloud, you even got those beginner skills down that you can add to your resume and apply in the future. Cloud is super awesome and it's not going away anytime soon. So I'm super happy that you guys chose to come out today and learn about this stuff. So yeah, be sure to follow McMaster DSC and Ryerson DSC for other upcoming events. I know McMaster at least has planned at least a couple more events for the rest of the semester, and we'll be continuing with full momentum next school year as well. So Ryerson and McMaster DSC both have the Instagram handles here. As well as you can look us up on LinkedIn. So if you search this name exactly, it'll come up with Ryerson and McMaster's DSC page. So I think we will share these slides with you after. There are hyperlinks here as well. Yeah, so if there's no last questions, maybe Kathy and Shardul, do you have anything to say before we end the stream?
Not much, just that we're happy to be working with McMaster's DSC chapter. So this has been a very new and exciting experience, and yes, continue full momentum onto next year. Hopefully things will be in person and we can actually do something, collaborate somehow in person, but we'll see how things go. I hope everyone stays safe, takes care of themselves, and thank you so much for sticking through this. I know it's a little long, but I hope you guys got something out of it. So thanks, everyone.
All right, thank you, Kathy. Do you have anything to say, Shardul, before we end?
Thank you guys, covered pretty much everything.
Yeah.
Thanks again, everyone, for showing up. I know this was a busy time of the year with a lot of midterms and projects you might have, but thanks for showing up and going through this with us. And obviously, yes, we look forward to working with Ryerson in the future. And well, we won't be here, Miranda and me, but our chapter will continue to work together. Thanks, everyone, for showing up.
Sorry, one last thing to say. These videos, the live will be posted on both the McMaster DSC and the Ryerson DSC YouTube channel. So if you need to reference anything, these videos will be up for you to see. And I think that's it. All right.
Absolutely. So thank you so much, guys. And I hope to keep in touch with you if you ever want to reach out or join our events in the future. Yeah. So thank you.